Good evening, everyone. We will start the session at 8:05 p.m.
Sir, will this session be useful if I am not attending the lecture week 8 content?
Yeah, anyway, we are going to discuss week 8 open session for week 8, right? So, yeah, we will be discussing the topics you may attend. Okay, fine. So, let's start today's session. So, till now, we have learned what different types of, or let's say, different methodologies of approaching problems in the algorithm world. Like we have learned greedy approach in the last week, right? So the basic idea of greedy approach is where you try to take the best possible option available to you right now at a particular instant of the algorithm, or let's say at a particular iteration of the algorithm, right? And then we will assume, not assume, we will think that okay, if I take the best possible option in my current situation, or let's say in my current iteration of the algorithm, then in the near future when I reach the end of the algorithm, then also I will get the best possible result. So to sum up in a different manner, greedy approach chooses the best possible option so as to and assumes that we will also end up at last with the best possible overall result, right? So it's like taking the local minima and assuming, or let's say always driving towards the local minima and assuming at the end of the day you will end up at the global minima or maxima, whatever. So this is the kind of approach in greedy. Now another way, there are different ways of approaching problems, right? So you can solve the same problem. Not always, it's not that always it happens, but sometimes it may happen that a particular problem can be solved by different approaches. So one of them is greedy approach, right? Another one is dynamic programming. So we will see that in the upcoming week. Another one is the divide and conquer, which we will see in this week, particularly this session. So these are different approaches of problem solving. So different philosophies of problem solving. Now, so what is divide and conquer? We have already seen code of merge sort and quick sort. We have seen that. So those are examples of typical examples of divide and conquer algorithms. now, but we have not seen them from a perspective of divide and conquer, but from a perspective of sorting. But today we will also see that why they are called divide and conquer. Maybe if you are familiar with the algorithm, you should be able to figure it out, because ultimately what we are doing in merge sort, that we are breaking a larger array into, or list whatever, into smaller part, two smaller part, and then independently we are sorting the smaller parts. And after they are getting sorted, the sub array, the two sub array that are formed, they are combined. I mean, so you basically then use the merge algorithm to pick to combine those two sorted array, right, into the larger subarray. So this is the way divide and conquer algorithm works. You divide the larger problem into smaller sub problem, then you solve the smaller sub problem and combine the result of the smaller sub problems so as to answer the larger problem. Okay, so you divide and then you conquer the smaller problem, that is solve the smaller problem and then merge. Okay, so actually the algorithm is mostly called divide and conquer, but it's aptly it should be called divide, conquer, and merge. So because the last step is merge, where you merge the result, I mean the solved sub problem and merge it into the larger problem, right? So this is how it works. I will so even quick short also. So what do? You divide the larger array into smaller part by using the partition algorithm, and then you basically, yeah, repeat that. So wherever you're dividing a larger problem and solving independently on the subparts, those kind of problem solving approach is called divide and conquer algorithm, or I mean, so those kind of algorithms where we are doing it in this manner, they fall under the divide and conquer category. Okay, so we will see some examples, and we will also revisit quick sort and basically not only quick sort but the partition algorithm we will revisit and see some optimizations that we will make on that so as to improve the time complexity. So primarily we will see a few examples of divide and conquer approaches, and then we will move on for quick sort and the partition algorithm. We will see a new approach to do them so that we get a better time complexity. So what was the worst case time complexity of quick sort? It was order n square, right? But here we will see that we can do something about it so that we can always get a n log n time and do not end up with. So randomization is one thing, but randomization may not work in all possible scenarios, because it may so happen that the data set on which you work, maybe even randomly chosen, your pivot might not perform that well. But in a general scenario, random quick shot works. But still, here the solution that we will see in this week is a 100% solution, foolproof solution. So it will work in every possible manner, and it will also guarantee a time complexity of order n log n for quick shot, and some other algorithms where you can use the partition the partition approach. So let's start.
I
Anyone
just
has
have
a
a comment. So I just
yeah.
wanted to, like, now that we have learned all the greedy algorithms and now 1 week on divide and conquer, what noticed is the greedy algorithms are pretty intuitive, simple to code and all that, and also very space efficient because you are kind of utilizing the same space. But of course, the only disadvantage I see is it sometimes can produce inaccurate output because it can get stuck in local instead of global. Uh,
Correct.
Whereas a divide and conquer, it will always guarantee to give the optimal solutions. And second thing is because of this recursive nature, we are breaking a big problem into two identical sub problem, and even the optimality is not destroyed. So we can
Correct.
inherently take advantage of parallel CPU structure, right? So we can get advantage in the time complexity, right?
Yeah. Yeah.
Right. The only thing I would say is understanding perspective. It's slightly more complex. And now the merge part that you talked about, after we get the result of the sub problems, you have to combine them. So there is a little bit of overhead,
Exactly.
with the stacks and all that. So that's the only part I would say
It's difficult.
difficult. Yeah. So
Exactly. Even the as you rightly pointed out, the divide and conquer part is not that difficult, because that's what happens recursively. But merge part is the main part where you are doing the, I mean, the core of the algorithm. That's where you forget about merge sort. We will see few other divide and conquer algorithms today, and you will see the merge part is the main part where you have to actually use the, I mean, the core, the idea of the algorithm that you have to use over there. So yeah, it's difficult in that respect. The problem with greedy is, again, as you rightly said, if you greedy is an elegant solution, but the problem is that solution does not exist for most of the problems. So yeah, that's the problem. That's the issue. Most problems in real life do not work with greedy approach, right? So yeah.
So students are greedy in general. We are always greedy about marks.
Okay, so now let's start today's session. Then we will no, just a second. Okay, so first is the counting inversion problem. Now, just so what is counting inversion? Let me just go over there. As you can see, let us say that you have this. Yeah. So, for the sake of example, let's say here what we are trying to do is. Just a minute, I'm facing some issues here. Okay. So, what is counting inversion? Uh, Fine. So, let's say we have this ranking. Now, what is ranking? See, is D, A, B, C, whatever it is. Let's say these are some, you can consider them movies. Like in this lecture, we have considered each of these as movies. You can consider them book recommendation or anything. So, any book or movies or something like that. And what we are trying to do in this problem is we are trying to find, or let's say make a recommendation system. So suppose I like a few movies as a person, and I select that, okay, these are the movies which I like, and my order of preference, so I like the movie D most, and then I like movie B, and I don't like movie E that much. So the leftmost character is that movie, represents that movie which I like the most. Okay, so that's what this DBCAE means. In the order of preference, D is the most likely and E is the least likely movie that I would prefer to watch. Now, this is so therefore accordingly we are also allocating a ranking value. So D is 1, B is 2, likewise, like C is 3, since according to this order. So we are assigning a ranking. Now these are my ranking, right? Now you are a separate person, and you also have a separate ranking according to your choice. So your ranking is this thing, B, A, C, D, E, right? So so you like the movie B most, and you don't like movie E, right? So accordingly, and all the other movies are in between. So this is your ranking. Now what we are trying to do over here is we will try to count the number of inversions between these two let's say these two sequences. So what does that represent, right? So that's the question, that if I, so what first of all, what is an inversion? So inversion means that let's say I have this D movie, then B movie, then C movie, A movie, E movie. This is my sequence, and your sequence is B movie, A movie, C movie, D movie, and E movie. Okay, so now what I will try to do is there any such pair of movie between these two sequences where I like let's say in that pair I like a movie and you don't like that movie. So let's say, okay, let's say it in this manner. Let's say I have a pair is such, I comma j pair is there. I is a movie and j is also a movie, right? So my preference is I greater than j, and your preference is I less than j, right? If such a pair ij exists, then I will call it an inversion. So in easier terms, I am keeping a particular movie on the left hand side and another movie J on the right hand side, but in your sequence J is on a left hand side and I is on right hand side, right? So that's a contradiction. That's such a pair where we are calling it an inversion. Okay, so in this example, let's say B is there. So in this example, if you see B and A, so B is on left and A is on right of B, right? This pair B comma I. And in this sequence also, B is on left and A is on right. It need not be one after the other. The point that I'm trying to say over here is I also like B more than A, and you also like B more than A. So now if there is something in between, how much I like, the notion of how much. So let's say you like B the most and A is just after that. I like B not that much, but not that bad also, because it is at rank 2. So I like B, but I don't like A that much. I like A, but I don't like A that much because it is towards the end. But you like A quite a lot, right? Because it is towards the first. But in both cases, B is better than A. I also agree with that, and you also agree with that. So the notion of how much likability is there is not in our question in this algorithm. Only the point is that we would try to find the pairs where I like a movie. I like some movie better than the other. I mean, more than the other, but you like the other one first, and the one that I liked more, you don't like that. So that's what inversion is all about. So here it's not an inversion. So BA is not an inversion because in both cases B is on left and A is on right. Can you tell me a inversion, such an inversion? I can see one. Can anyone tell me?
C and D.
AD. AD.
AD?
Yeah.
So
A is
AD,
last for the U and A is before me.
correct. So AD is an inversion. Anything else?
CD.
CD is an inversion. So there D is there. Yeah, CD is an inversion. Right? CD is an inversion. Even AC is an inversion. Right. So this is the point, as you can now see. And one another elegant way of showing this is as it's already there in the slides as well. You can just
BD.
so wherever there is a crisscross, right? Wherever a cross is formed, that's a inversion. As you can see here, this is a cross, right? So let me just mark it in different colors. So this is one cross, this one with this one, right? So that is corresponding to the AD pair. Correct. Now let's take another example.
What was the other method?
The other method is just observation. It's not anything. I mean,
Okay.
it's just observation. So another color, another option cross is this one, right? So let's say this one, C with this one. This is another cross. So this is corresponding to the CD thing, right? And another cross can be the AC one. Let's say this one with this one. So which is corresponding to AC. So wherever a cross is being formed, right? So that's basically indicating a inversion. But anyway, so that's a visual way of just confirming the thing. But the idea is wherever a pair I comma j is I is a let's say one entity, j is one entity, and I prefer I more than j. but in your sequence you prefer J more than I. So if such a pair exists, then we call that an inversion. Okay. Now, coming back to our problem. By the way, so let's take it. So what I'm trying to make is we are trying to count the number of inversion in two sequences. That's what we are trying to do. Can you tell me what would be the benefit, or what will we gain by counting the inversion? What can we do with that? So, in a practical aspects, yeah.
Sir, maybe because we had this Kaziranga house allocation, right?
Okay.
Sorry, Kaziranga, there was a companion program. So there were like three choices, right? You can choose three people as companion. The other person who you're choosing has to also choose three people. And then in that preference, it has to be seen who is preferred more or something. So I thought maybe that is something we can use version there.
Actually, we can do a little more better than that also by simply using these inversions. A little more, let's say, more insightful. What you can do is you can group people depending upon their mentality. So that's the nice thing that you can do, because let's say you gain multiple. I mean, so for you have many people, many candidates. What you do is you ask them to give their preference of a particular thing, or let's say you give 10 movies and you ask them to rank them depending upon their choices. So whatever is their preference of their 10 movies, or 10 books, or whatever, something, 10 subjects, 10 courses, 10 actors, whatever. So you do that, and then what you can do is you count the inversion between pairwise inversions, right? So take every every pair of person, and then compare between their sequences. So the ones where you have least number of inversion, they indicate their likability. So basically their choices are similar. So even you can use this in now, as you can guess, this gives us a notion of likability of individuals, how their mentality is. So these kind of things can be very beneficial in multiple, let's say, where basically where pairing is done. So let's
Like
say your
dating websites.
right, dating websites, your marriage websites, matrimonial websites, right? Many and other things. Let's say some teamwork, right? Where you basically allocate teams, you make teams, something like that. So, anyways, so even where you design a project team, so you ask them on which technologies are you more comfortable in, right? So you can have a large pool of people, and then you can take them in that manner where the inversions are less, so that they can gel up better, right, in the team. Anyways, so that's the point that I'm trying to make now.
Sir, when we'll work on this, I'll also contact you again.
Okay, sure.
So one thing is that when the people are being grouped, you are grouping people based on their similarities and dissimilarities. For example, let's say we're talking about movies here.
Yeah.
There are 10 movies, and then let's say there are 100 customers or 100 viewers. So you first group, when you're comparing, are you liking the same movie and also disliking? Because essentially you're given 1 star as well as 5 star, right? So you're looking at from a likeness perspective, both the extreme, right? The likeness and the dislikeness. And when you are agreeing in your both the preferences and dislikes are similar. Right?
Similar.
So that is the first step, like you are grouping people together. Now the second thing is, now you belong to a cluster or a group. Now, of course, you will not be exactly same as your cohort or house example that one of the students was talking about, right? Then the beautiful thing here is, if I look at the cluster preference, let's say in the cluster there are 10 people, out of which 6 people have watched a particular movie and rated very highly, and rest 4 have not watched it, then it becomes very interesting. Then the algorithm will say, okay, the other 4 who belong to cluster 1 have not watched movie number 6 but liked very well by the other 6, then it becomes a recommendation criteria, right? So this is how we would actually use this 2 things, grouping and analyzing the inversions, actually do a practical recommendation on your cross-sell, upsell. I think Netflix, you may want to like this,
Exactly.
or Amazon will say, market basket, like, you other people who like you bought this book, right?
Exactly. If you watch your Netflix a movie, I mean, at the bottom part of the screen, it recommends other movies of similarity. I mean, same kind of movies, right? So those kinds of recommendation systems work very easily on this. Now, one important point, since we are talking about recommendation system and you guys are anyway doing machine learning stuffs, so recommendation system is one of the basic project of machine learning applications. But before going in, so you can use Bayesian and all of that, but before going into that, this is something which is very, I mean, let's say very easy to do. It would take you a half an hour or 45 minutes to code the thing up, and you can actually get proper insight. If you have a large data, then you can actually do it. It's quite nice, right? So yeah.
So
Anyway.
Netflix makes 30% of the revenue based on this recommendation, even Amazon. So there is actually a big business,
Yeah.
millions of dollars. Yeah.
Yeah. But the thing is, they are not using any of that. It's ML basically. But anyways, this is the start. Now, see, let's say, what's the next thing that you can do? This algorithm does not take care of the, the amount of likability. So as the thing that I said, that here D is earlier and let's say E is later. But here D is the best and E is the worst. Here also D is earlier and E is later. But D and E both are towards the end. So as you can see, this part, how much are you liking? Okay, you are liking D more than E, that is fine in both the cases. So I would kind of group these two people in the same cluster. But again, I'm intuitively maybe they shouldn't be there in the same cluster, because here D is towards the end and here D is the best movie for this person. So that part is left. That part is not addressed. So in order to address that, we have to think of something else. And because of these other, these nuances, we go for, when you actually make a proper advanced recommendation system, we go for some other techniques. Primarily, they are the statistical techniques. Okay. Fine. So, but let's come back to the topic now. So, what we are trying to do in this algorithm is we are trying to find the number
Sir,
of...
how we are guaranteed that there is n into n minus 1 by 2 similarity?
No, not guaranteed. That is basically, how many possible inversions can be there? Number of inversion ranges from 0 to this much. Right? So let's say you have two sequences are such that all the pairs are inverted.
So
Right.
NC2 number of pair and they are inverted. All they are inverted.
Yeah. You have n numbers are there and all of them are inverted. So invert means what? You are considering in pairs, right? I told you inversion means a pair I comma j, right? So if you are basically taking two numbers, so from n I am taking two number, therefore n choose 2, which is n into n minus 1 by 2. So this basically means I have given you two sequences such that every pair are inverted pairs. So basically, if you write these two, everything will be cross, something like this.
But wouldn't the pairs be like half? Oh, okay.
No.
It's like if I have DB, right? I won't.
So something like ABCDE and EDCBA.
Yeah, correct.
Like, can we take a very short example for this? Maybe like 3, A, B, C, and C.
Okay.
Sir, recurrence relation will be important for exam point of view, quiz 2.
Sorry, what? I couldn't hear you properly.
Recurrence relation.
Yeah. But
Okay.
we will see that. We will tell you. Only basically you need to solve the recurrences. We will do that in this class also. Fine.
ABCDE.
Let's say ABCD.
DCBA.
Right. So if this is the case, let's say
There should be 6, right? Maximum.
So for A, everything, all of them would be, sorry.
Yes, sir.
As you can see, for A, all of them would be an inversion.
Yes.
For B, all of these are inversion. B, C, A. Why? Because here B is after A, here B is before A. So all three are inversion. For C, all three are inverse. So basically for each one of them, this whole thing would be invert. One less than the whole thing would be inversion. Right? So therefore you are getting n into n minus 1, and because we are considering in pairs, that's why it is 2 by 2. With simple combination, just choosing two numbers from n, that's base NC2 will be there, and NC2 will be basically the measure of dissimilarity. So fine, but there is one little trick that we are doing in this case. So let's come back to that. Not trick, simple way of problem solving. So what we are doing is, so my ranking or one of the primary ranking with which I will compare, right? So I am fixing the rank 1, 2, 3, 4 accordingly. So if D, B, C, A, E is my ranking, so I will say D is 1, B is 2, C is 3, like that. Okay, so if this is the case, then my friend's ranking would look something like this, and my ranking would look what? 1, 2, 3, 4, 5. So this is my ranking, and this is my friend's ranking. Fine. So as you can see, why we did that? Because 1, 2, 3, 4, 5 is a sorted sequence, right? It's a sorted sequence, and by having this, I mean by using it in this manner, that so that I get this in numeral value, this number values, right? 2, 4, 3, 1, 5 or whatever, this number values. What we will do is we'll use the merge algorithm that we learned in our merge sort class, right? And we will use that to count the number of inversion. Now you can see that we can simply write a code to count the inversion, right? And that would take you how much time? N squared time, because what you will do is you will run 2 loops. One inner loop will go through the outer loop will go through the primary pattern, my pattern, and the inner loop will go through the my friend's pattern, and I comma j will be compared whether they lie or whether they are in accordance or not. So but that would take you 2 loops, so it would take you n squared time. So I'm trying to do something which would take lesser time. So how can we do that? So counting the inversion can be done in a lesser time by using the merge algorithm. Now let us see how to do that. See, one point is there. Fine. So what we will try to do over here is we will take the friend's suggestion, whichever, the friend's permutation, this thing. So let us call it I1 to IN, right? Obviously, this is a unsorted sequence, right? Because my sequence is 1, 2, 3, 4, 5. Remember, according to that only I have numbered the preferences. So if I like, again, just keep this thing in mind. If I like the movie D, A, C, B, so then I will say D is 1, A is 2, C is 3, and B is 4. And if my friend liked A, B, C, D, this is my friend's suggestion, then actually the sequence that I'm trying to count the inversion would be, therefore A is 2, so 2, B is 4, C is 3, D is 1. So 2, 4, 3, 1. So 2, 4, 3, 1. This is the sequence in which I will try to find the number of inversions, right? So, and why we are converting it into numbers and doing it in this manner? Because merge algorithm will then help us to count the number of inversion. Why? Because merge would basically, basically compare, or let's say compare 2 numeric subarrays, right? So since here I have this 2, 4, 3, 1, I am converting into this number array, so I can use merge algorithm to count the inversion. Now how to do that? Let's see that. So how does merge algorithm works? Let us see that. If I go to the example over here, I think one example was, okay, no. So how does merge algorithm works anyway? So let's take something. Let's take 8 or let's take 2, 6, 7, 9. Right? And let's take another subarray where it is 1, 3, 10, 12. Fine. So these are the 2 subarrays. This is 9. So these are the 2 subarrays that I'm talking about. and I will now go for the merge algorithm between them. So if I run simple merge, the merge
Say,
program.
but like if we are counting inversions and we have 2, 6, 7, 9, like shouldn't we have like the same kind of numbering for the second one?
Oh, I'm not talking about particular. So okay, so that is fine. But here I'm just kind of representing the how merge works. But
Okay.
anyways, what was your exact doubt? Shouldn't they have?
So like we had A, B, C, D, and we were saying that let's just label them 1, 2, 3, 4. And then we were kind of jumbling them. So we were jumbling that set of numbers only, right?
Yeah. So see, what I'm trying to do over here is, uh, let's say I will come to that. But okay, so I will answer your question. But let's at first see this. Okay. So what we will do, this sequence, this breaking these two sequences coming by, see this step, merge L equal to this I1 to IN by 2 and R equal to IN by 2 plus 1 to IN. So this is basically my friend's sequence, right? The sequence that my friend chose. I am breaking that sequence into two subarrays. One is L subarray, another is R subarray. So half of the elements, so let's say there were 8 movies. So 4 movies would be in L and 4 movies would be in R. So this is your L and this is your R. Got the point? What I'm trying to say. So that's how this LNR is getting generated. Okay. From my friend sequence. My sequence is 1, 2, 3, 4, 5. So forget about that. But my friend sequence, whatever I got, I1 to IN, I'm breaking that into two subarrays. The first part is I1 to IN by 2 and the other is IN by 2 to IN by 2 plus 1 to IN. So I'm breaking it into two equal halves. So even if it is not equal, if it would have been odd number, doesn't matter. So first, let's say you take first 4 elements and then in the next one you take 3 elements. So basically what I'm trying to do is I'm breaking into two subarrays like merge used to work. The same sequence that my friend gave, right? So that's how LNR is getting generated. Left subarray and right subarray of the sequence of my friend's of my friend's suggestion, right? Fine. But after breaking, what happens? So this is, let's say, L and this is, let's say, R. What we are trying to represent over here is how the merge algorithm would be able to count the inversion, because that's the main point, right? I'm trying to use the merge algorithm to count inversions. Now, what I mean is L and R are these two, right? So my friend's actual sequence was 2, 6, 7, 9, 1, 3, 10, 12. Okay, I mean, forget about the missing numbers. I mean, 4 is, I think, not there. So let's say 4 would have been there. Okay, so let's yeah. But let's say this is the sequence that my friend gave. So I broke it down at this half, and that's how I got LNR. Fine. Now, how the merge algorithm works? So that's we will see. So how generally the merge, how will it work? It will consider L, the first element of L, right? At first 2, and then it will compare 2 with 1, right? So yeah, so it will compare 2 with 1, and whichever is smaller, that would be put into, I mean, the temporary array or the combined array. So what we will do, so here 2 is compared with 1 now, and 1 is the smaller number, correct? So what we will do, 1 in merge algorithm, 1 would be put here, 1 would be removed, and then which one is compared? 2 is compared with 3, correct? In the next I mean, in the next group, in the next iteration, 2 is compared with 3. So that's how the merge works. Now, how the inversion will work here, see. When I am comparing 2 and 1, and 1 is the smaller item, I'm putting 1, I mean, taking aside 1 earlier. What does that mean? 1 is smaller, but 1 is in the right-hand subarray. Okay, just be careful over here what we are talking about. 1 is in the right-hand subarray, and 2 was in the left-hand subarray, left subarray. When I compared 2 and 1, 1 became smaller, and that's why I removed 1. But what does that indicate in terms of the sequence of likability? That means 2, 6, 7, 9, these 4 numbers which are earlier. Remember, I told you the original sequence that my friend gave is 2, 6, 7, 9, 1, 3, 10, 12. I did not rearrange anything. I just broke it down over here. That's why this is I1, 2, IN by 2. Just simply breaking it down. No rearranging. So that means in the original, whenever I'm doing to comparing 2, 1 and 1 is being placed. So this essentially means that since the first element of right subarray is smaller than the elements of left subarray, that means all the elements over here are inversions with respect to 1. Try to think it. Why is it so? Because right subarray first.
So my ranking would be 1, 2, 3, and so on, and the friend's ranking is this what he has given me, and because of that, when it is if the values in the left side are greater than 1,
Exactly.
everything is going to be an inversion.
Exactly. Right? If the values on the left side are greater than not only 1, basically whichever number I'm comparing. So now the number on right is 1. So with respect to 1, everything on the left is actually larger. Right? Because 2 is the smallest element, that is larger. That means any element after that would be obviously larger than 2 and therefore obviously larger than 1. And that's why I can say that all the element on my left subarray are larger than 1, and that's why that's a, I mean, that's an inversion. Now here I can see 1, 2, 3, 4, but when you run the algorithm, you won't see 1, 2, 3, 4, right? It would work automatically. So the point is, when the first element of left subarray is larger than the first element of the right subarray, that essentially means all the element of the left subarray is larger than the first element of the right subarray. Why? Because all the element would be lesser than this. I mean, 2, then 6, then 7, then 9, right? So all of them would be larger than the first element of the right subarray. So all of them would be inversion with respect to 1. Okay, and that is actually the case. As you can see here, 1 is here and 9, 7, 6, 2, all of them are larger than 1. So if you simply, because our sequence was 1, 2, 3, 4, 5, 6, right? So all of them should be actually after 1. So that's why here, simply by comparing 2, 1, we can tell the number of inversion is how many? The length of L in this case. For the first iteration, while comparing 2, 1, I figured out 4 inversion. You see that by one comparison, we now know 4 inversions are there. But if you would have done it in a inner loop kind of manner, then you had to find this by doing 4 different iterations. So for each of these inversion, there would be one I, j pair corresponding to which the inner and outer loop will run, and for that particular execution, you will find the inversion. Right? So for 4 inversion, you have to actually go through 4 iterations, 4 particular iterations of the inner and outer loop. If you do it naively, simply by running 2 loops. But in this case, by actually making one comparison, we figured out that there are 4 different inversions here. Right? So that's where the timing improvement is coming. Right? You don't need to go through so many iterations. That's where you are getting the benefit. Anyways, so that's done. So 2, 6, 7, 9 is, so you simply count here. So okay, first of all, I'm trying to also count the inversion, right? So all you need to add over here is normal merge algorithm with a count variable. So where you basically, when you do the normal merge, write the normal merge algorithm, you would have a count variable where you will count how many inversions I'm getting at this level. So while comparing 2, 1, I got this 2, 6, 7, 9, 4 inversion. So you allocate count equal to 4. Right, and then you simply add upon that. So okay, so first step is done. So why I got 4 corresponding to the comparison between 2, 1. Okay, after that what will happen? So next number is what? 2 is compared with 3, right? And now I see that 2 is the smaller one. Correct? 2 is compared with 3, and now we can also see that 2 is the smaller number now. Right? So since 2 is smaller number, 2 would be taken at first. That means it's not an inversion, right? Because the left hand side is the element on the left subarray is smaller. That's how it should be actually. So since the element on the left subarray is smaller, therefore I can say it's not an inversion. Okay, so fine, that is actually true. So no inversion is there, it's okay. So I take 2 and place it. What is the next comparison that will happen? 6 and 3, right? 6 and 3 would be the next comparison. So again 3 would be smaller. Now again a problem. Since 3 is smaller, you can guarantee that okay, 3 is smaller item, but 3 is on right subarray. So whatever is left over in the left subarray, I mean in the whatever is there in the left subarray are definitely bigger than 3, and that's why they are definitely an inversion with respect to 3. So simple, again by one comparison between 6, 3, we can guarantee that there are 3 possible inversions, right? Because 2 is already out of the question. 2 I have taken out. Remember that. So 6 and 3 are being compared, and with respect to 6 and 3, I have these 3 inversions. So that's how the algorithm proceeds, right? So every time you make a merge, whenever the element from right subarray is smaller, whatever is present in the left subarray corresponds to an inversion. And that's how you do it. So after that, corresponding to 3, you get this 3, and this is comparing 6, 3. Okay. As you can see, after this, there will be no further inversions, because after 3 goes away, I will compare 6 and 10. Now 10 is a larger, so 6 would go. So again, no issues. Then 7 and 10, 7 is smaller, so 7 will go. Then 9 and 10, then 9 is smaller, 9 will go. So all the 3 elements are being picked from the smaller, I mean on the left subarray. That's why they are not inversions. Okay, and then finally 10 and 12 will be added. So the merge algorithm has this beautiful way of working while you are basically taking. So whenever in the merge algorithm you are taking an element from the right subarray, that means the element of the right subarray is smaller. Whatever would be there in the left subarray will correspond to an inversion. Fine. So we just need to add a count variable in the merge code. Let us see that. So this is your merge code. Okay, I will not discuss it in detail. I hope you all know that. Only one count would be there here, bus. That's it. This is the only change in code that has to be accommodated. Nothing else is, and this line. Okay, so as you can see, when we are doing C dot append bj, right? A and B are the 2 subarrays. Whenever I am taking the element from the B subarray, that is the right subarray. A is left subarray, B is right subarray. So whenever I am taking an element from the right subarray, right, in that particular scenario, only count would be increased. Okay. And by the way, what is counting? Why count plus m minus I? The m minus I means what? M is the length of the left subarray. I means the iteration which you are currently at. So I'm subtracting that to find the number of element left over at that particular moment, right? So like in our example here, I saw after 2 is being removed, only 6, 7, 9 should correspond to the inversion. So m minus I will cater to this amount, that at ith iteration, how many elements are present in L. Okay. That's it. That's the merge code. As you can see. How many of you have doubt? You can ask your questions.
Sir, one question I have. Suppose there are 0 inversions in between two.
0.
Hello,
Sorry.
sir. Am I audible?
Siddharth was asking something, but he's not audible.
Hello, I'm not audible.
Yeah, audible, but yeah, continue. Please continue.
What I was asking is, suppose there are 0 inversions between 2 arrays, then does that mean that the 2 arrays are exactly the same, or
No, the numbers might be different, but the thing is they are all, I mean, basically, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 to 5 and 6 to 10. These are 2 numbers, 2 subarrays, right? There will be no inversion.
okay.
Anyone else has any doubt? Inversion means
Sir,
I,
my doubt is
yeah.
regarding merge code. I have just implemented it,
Okay.
but I am merging in little bit different way, means using while loop 3 times. So
Okay.
I think this is sorting very correctly, but I think there is some mistake in counting. Could you see on the chat that where should I append the count so that I get the correct?
Okay, so I will do that, but since it will might take some time, I don't want to do that in the middle of this discussion. I will do that at the end. Okay, please remind me.
Okay,
if you are
sir.
there, and if you are not there by the end of the session, just post it on Discourse. Okay, and tag me.
So like intuitively, when there are two people like me and my friend, if they belong to the same clusters, then inversions will be less intuitively, right? Because they are similar, so there will not be a lot of greater or less. So when we say
Yeah.
less inversion, you are more likely to be part of the same cluster.
Yeah, but here I mean, basically the thing is we are trying to put them into different categories by counting the inversion. So you don't have the clusters. You are counting the inversion to put them into clusters. So yeah, that's
Right.
But so what's more important over here is your idea. You should be, so let me tell this in this manner. Let me put in this manner. See, uh, so normal, when I ask you a normal, forget about all of this, and when I ask you, you have to count the number of inversions. Now inversion is not that of a very uncommon concept. It's a very general concept. Even in mathematics, you in sequence and series you might have inversions, and all of those things are there. Basically I comma j, two numbers are there. In one sequence I is earlier, in the another sequence j is earlier. If such a pair exists, that's an inversion. That's it. That's the simple mathematical way of defining it. And you have to count the inversion. That's it. If this is a normal question like that, and we just let's say take out the physical importance, let's say this movie recommendation, book recommendation, just take out all of that and simply consider I comma j, two numbers. I is earlier in one sequence, j is earlier in another sequence. If such a pair exists, of two numbers I comma j, I need to find out how many such pairs there. So you can simply run two loops and finding it out and find out. But the idea over here is, the beautiful idea over here is using the merge algorithm. Now that is quite counterintuitive. It will not come to mind early, very fast, that okay, where does the merge algorithm click in? The number of inversions quickly, right? So the let's say after this discussion, or let's say after you rewatch this, or maybe the lectures, the primary vision of this would be for you to appreciate the fact or understand the fact why merge is able to count the inversion in a better time. That is the most important part. Okay, so if someone has doubt in that part, you can ask. So yeah,
So
anyone has?
merge sort is having complexity in log n. So
Yeah.
we are doing the counting of invergence in n log n time instead of n square time. So that is the benefit we are getting in this.
Yeah, but here it's not in log n time actually, because merge sort works in n log n time, but here it's only the merge algorithm. So merge algorithm works in order n time, right? So this is a simple order n algorithm. But
But
that
sir,
is
there could be invergence in, suppose you have this L and R, right? So this
yeah.
L and R, there could be invergence in L and R also. There could be invergence in L subarray and R subarray also, which we have to consider. So for that we have to do recursion.
Yeah. Okay.
Yeah, but
So you are telling from that perspective that yeah, one iteration it is only order n, but yeah, when you are doing it recursively, then the recursion will click in and you have to find out. Yeah, that's correct.
So,
Correct.
coming back to the question which I asked
Coming back
earlier,
to the, yeah, so the whole algorithm will end in n log n time only. That is fine. That is
so
correct.
that is okay, sir. But coming back to the earlier question which I had asked, we have we have two sequences. Like for the example which we had of the films, I was giving one particular sequence and my friend was giving some other sequence.
Okay.
So suppose there are zero invergence between our sequences. So
Yeah.
does that mean our sequences are exactly the same?
It obviously it might be the number of movies are same, right? And
Number
if
of
there are,
movies are same, yes.
and there are zero inversion, no, your sequence might not be same.
sir,
Only
if there is a case that, like if we took the case of the first alphabets, it was like jumbled one case. Second one, when we consider, it was like numbers and it was already sorted, like order of 1, 2, 3, like that. So in that case, it was easy to find the inversions of the front case when it was, we are sorting in the number order. But if the case is that the first order only is not in like ascending order or something, then how are we going to find the inversions for the second one?
sorry, can you repeat? I was just thinking of this other thing. Can you repeat what you asked?
Sir, in this case, the first case was, it was ordered like 1, 2, 3, 4, 5. That was a sequence, and this was a friend sequence, right?
Yeah, so it's not ordered. The idea is whatever was the movie list or whatever my choice was, I am putting 1, 2, 3, 4 accordingly. So let's say A movie, let's say C movie is my choice. So C first choice. So C would be correspondingly mapped to 1. And wherever my friend has put the C movie, that would be 1. Right? That's what I'm saying. So that's what I was saying earlier. So if I liked C most, and then B, and then D, and then A, so I will map C with 1, B with 2, D with 3, and A with 4.
Okay.
Now my
noted.
friends, yeah, so my friend liked ABCD, suppose this is my friend sequence. So this will be 4, 2, 1, 3. Right?
Then it's perfect.
So in that case, the suppose that there are no inversions between the two sequences, then in that case the sequences have to be the same, sir. Because
That's what I'm thinking. Yeah. So 16492, let's say a sequence is there. Okay. And
Instead of that, first itself is 1, 2, 3, 4, 5, sir. In the sense, I am giving 1, 2, 3, 4, 5 as the first one. So
1, 2,
obviously,
1, 2, 3, 4, 5 is my choice, right? So anyway, that would work.
so here there are
his
inversions
choice
in that case.
Anyway,
here is 1649.
So let's find. So okay, we'll keep it 1 only here.
Another question just related to this. Suppose there are n into n minus 1 by 2 inversions. Does that mean the sequences are exactly opposite to each other? Suppose
If there are exactly n into n minus 1 by 2 inversion, then that means the sequences are exactly opposite to each other. Okay.
Yes, yes.
And even I think this is also correct, because if there are exactly zero inversions, then also the sequence are same, because you are restricting the number of options, right? So the movies are fixed. The movies are fixed. It's not numbers, it's movies.
So you can take that diagram which you drew, in which you connected the two
Lines,
vertices.
right? Yeah. So everything would be parallel in a zero inversion.
Yes.
Right. So either it may not be directly like this parallel, but it will be something like this. It will be parallel. But anyways, yeah. So it would be same.
Yes.
Second time you put that parallel, it will be wrong, sir, because at some place it will cross. So first one parallel only is correct.
No, it can be something like this also. Let's say okay. So 1, 1. Three is here.
Yes, sir. There will be invergence in this case, sir.
There will it will cross.
Yeah, there'll be, because one number has to be earlier.
In this 1 and 3,
So yeah,
some number will come.
one
No,
at least one inversion will come. Yeah, correct.
Yeah.
At least one inversion will come at some point. Even if I don't consider here, it will come later, corresponding to this.
Yeah. So
Yeah.
first parallel, it will be equal.
It will always be this parallel.
Inversions. Yeah, if there are 0 inversions, means his choice and my choice are both are same.
Correct. But one important point on that note also, if there is one inversion, then it does not mean that only one will be crossed. It might so happen that this parallel thing will happen in that case, right?
Yeah,
Why I am
there.
Right? This parallel might happen. Only one inversion does not mean only one cross, but zero inversion definitely means everything will be parallel. Okay. So that should be something we should keep in mind. But anyways, those are a little bit different off-track discussion now, because we are not trying to analyze the data. What we are trying to do is we are trying to analyze what algorithm to use to count the inversion in a faster way. So from that perspective, merge algorithm is used, and I hope you can understand that this would be recursively called. This algorithm would be called recursively on LNR. And LNR, this n by 2 would be happening in recursive manner, just like in merge sort algorithm. Only thing is we added this count to find the number of inversions that's happening. Okay. So again, it would be done, therefore, in a better way.
Sir, where is the recursion coming in this, sir?
Oh, recursion is on this, right? So wait. So I took the sequence over here.
Recursion is not there.
Yeah, it's there. See. So I took the sequence 2, 6, 7, 9, 1, 3, 10, 12, right? and I told that the original sequence, let's say suppose the original sequence is 2 6 7 9 1 3 10 12. This was the original sequence, but how can I guarantee that the first 4 would be sorted and the next 4 over here would be sorted? It might not happen, right? Always there can be, I mean, the first 4 might not be sorted, or if I have, let's say, n elements, the first n by 2 might not be sorted. So what we are trying, this is just one intermediate iteration of the merge algorithm that I showed. But in order to reach this this state, we have to actually iterate on these two elements, right? Normal merge algorithm. So it will swap them, and at a particular level, when 4 element arrays are formed, sorted subarrays, then the next merge will happen. Just like merge sort, no difference.
It is same as merge sort, only we are adding
Exactly,
the variable count.
Yeah, exactly. That's what I said. That only difference is this line.
And the complexity is also n log n only because of that.
Everything would be same. Just this count would be added. You can copy paste the merge code. Only this add this count. That's it. These 2 words you have to add.
So far, all the sorting, we are sorting based on values. This is the first time we are actually looking at the position or the rank or the index value, not the value in itself, right? So in statistics, in stats too, we learned about minimum of a random variable less than another one, right? So it is like that. So it is called order statistics in statistical.
Order statistics. Yeah.
Yeah, that is exactly so. So the values don't matter. It's actually the rank. So it is called ordinal statistics or non-parametric, basically statistics distribution. Yeah.
So that's the reason, because here we are not worrying about the let's say the values. The idea is where do you stand in the sequence that represents your likability for a particular movie or whatever, right? So anyways, so this is my normal merge sort code with a little bit addition of the count variable, and yeah, at last you have to return the total count. So that's what you're doing. Time complexity is this is the recursive relation. Normal merge sort, same thing, and you solve it, it would come to n log n. Now with respect to recursive relation, as one of you asked that whether it would be important for quiz 2 or not, so we might ask you, given a like this, we might give one of this recursive relation and ask you that what is the time complexity. So you have to basically solve it, right, by using back substitution. You have to solve it and then put the answer. I hope I discussed that in previous sessions in how to solve this, right, by using back substitution. So visit the, I think, week 2 sessions I have discussed in detail. We can do some practice at the end of the session if I get time. But anyways, for those who do not know, please visit week 2 sessions, how to solve recurrence relation.
So in this week also there is some concept of recurrence trees.
Yeah.
Which is also helping us to solve this. But
exactly. Recurrence trees, I will show that what are recurrence trees. I'll come to that, but now fine. So inversions is okay, right? How merge algorithm is counting inversion. Now let's come to the next topic. So this is the next example, and this is okay. This one I will come a little bit later, I think. Fine. So let's do this one first. Divide and conquer's next algorithm is integer multiplication. Now, how integer multiplication is used for divide and conquer? Let me ask one question at first. So this.
Sir, your screen is stuck in closest pair.
Oh, is it? Wait. Is it okay now?
Yes, sir. Integer multiplication, first page.
Fine. So before starting this algorithm, one very important point that is not addressed in the slides or even in, let's say, in the discussion, that this is a very important question from perspective of your coding or let's say interviews and all. So this question is how to, let's say I give you a number which is, let's say, maybe 1000 digits long, or let's say even more than that. Let's say it's around 2 to the power 10 digits long digit. Can you imagine it? 2 to the power 10 digits long number I have given you, or even if I make it a little bit smaller, let's say 2 to the power 5, or 2 to the power, not 2 to the power 5, 2 to the power 10 is fine. 2 to the power 10, or 2 to the, or, let's say 2 to the power 15, even 2 to the power 15 digits long number. That would be a very large number, right? So how can you multiply two such numbers? Keep in mind, if I have 2 to the power 15 digits long number, and I multiply them, then the answer would be how many digits long?
Sir, logarithm.
No, I'm
30.
saying multiplication, right? So 2 to the power 15 digits two number, yeah. So that means when yeah, 2 to the power 30 digits long
Sir,
number.
I said means if we want to multiply, we can use logarithm in shortcut to multiply.
How to use logarithm to multiply? It's a number which is 2 to the power 15 digits long.
Sir, it will break in addition, no, sir. Suppose we want to multiply a into b, so it will be log a plus log b.
So log of that many big number, right? Log of that 2 to the power 15 digit number. So
Yes,
that
sir.
itself would take time. Log, obviously log is done, but log is again done internally by some mechanism, right? So that would take time.
The Taylor series they went through a lot, which is quite a large.
Yeah, so that would take time. Here what the point that we are addressing over here is the whole PDSA course is about how internally the things are working. Because at the end of the day, you will write a utility function which is internally defined in a language, but at the end of the day, your timing would not improve. So that's the issue. So how to solve that? When I'm talking about integer multiplication in in such an advanced level, we are discussing integer multiplication, then that means we will discuss it at that grassroots level, right? Because where the timing is coming. So even if you use log, it will take a large amount of time.
Sir, it was discussed in the practice session yesterday, actually, the Karatsuba algorithm.
Forget about all of that. We will come to that. But let us at first answer this question. I have given you two numbers, and each of them are 2 to the power 15 digits long, and I need to multiply them. First of all, how do we multiply two numbers in a programming language? Put them into two variables and multiply, right? A equal to this, B equal to that. Multiply A and B, put into C. So
The
can we,
other way looking at is you put A into B times, sir. A plus
whatever,
A plus A
whatever.
plus B times.
Yeah. I'm talking particularly from program perspective. Now, if I ask you to give you two numbers or two data set, sorry, not data set, two numbers which are this long, can you put it into variables?
So max capacity is 2 to the power 31 minus 1 because we're using.
In Python, it is unlimited capacity.
I
Because
don't
we're
think it is unlimited. Can you use a number which is 2 to the power 60 digits long?
Yes, sir, Python has class structure, no, sir. It has infinite as far our memory does not get full.
Actually, that is also in a different way true. It will internally make it, but fine. But in classical languages, sorry,
The multiplication is basically addition only now, sir. Like
that's fine.
you
But what
add.
I'm trying to say is, if the variable limit exceeds, you need to work with numbers where the variable, the data type limit of the variable, that is not that much to hold that number. It is such a large number. When you need to operate on numbers like that, how will you do? That's the point, right? So let's say a particular variable, so let's say some X programming language is there, and for that programming language, whatever is the largest data type, so that data type is, let's say, some Y amount. It can hold a number which is Y digits long, right? 99999 Y times. But if I give you a number which is larger than that, then how can you work? Can you say that, okay, this programming language will not be able to work with such a large number? That's not the way, right? So how can you do that? Actually, this question would come in many coding competitions and many other places as well, where you have to use, let's say, Java or let's say C++ or some other classical languages.
Sir, we can approximate using scientific notations.
You need to
No, since we are
approximation.
discussing divide and conquer, we may think in that line, sir. Make it into half.
That's what we will do. But before that, forget about all of that. How will you divide and conquer will come when you are trying to improve the complexity. Now you don't have even a solution. You can't put it into a variable. You can't do so. You have just the number. Where to take the input? Tell me that. Right?
So
You need to have the
itself is
input.
problem.
Yeah, you can't put it into a variable. It's so large a number. What will you
Sir,
do?
here, let's say whatever the limit is, like 64-bit or whatever it is, right?
Yeah.
So if you put a number which is very large, you don't hold it in 1, you hold it in 2 or 3.
Nice. So how will you do that?
So let's say our limit is 2 bits, let's say, right? And if you're trying to enter a number which is 4 bits,
Okay.
then essentially the base is 10, let's say. So then we have positional value. So first position would be 10 to the power 3, then 2, then 1 and 0. Like if it is binary, of course, it would be 2 to the power 0 and all that. So we actually represent the number in adjacent cells, and it is respecting the property of the position value.
Correct. In
But
terms
we
of
cannot-
code, can you simplify it? Whatever you said is correct, but in terms of code, how will you do that? I mean, simple. You have already told it, but I just want a simpler answer to that. How will you just, so I want to take the input into something.
Modulo and the quotient and modulo. So essentially, the way to look at it is if I have ABCD, AB on the left hand side is my quotient, and the CD is a modulo, basically, right? So that's how we should look at it, the entire number ABCD.
Okay.
Sir,
Yeah.
Hexadecimal.
sir, one way I am thinking to multiply this number, this is brute force. There are 15 digit on one number and 15 digit other number.
Okay.
So there are total 15 times 15 2 to the power 55 possible multiplications. So I will multiply 2 to the power I will multiply 215 25 and 225 225 numbers. I will multiply 225 number and add them.
No, but thing is, we are not able to take the
No,
input
no.
at all first.
Forget about
will take-
multiplication. Just tell me where to take the input. That's what I'm asking now.
How
Input.
to take the input?
Yeah, you don't have the
I will
input
take
even.
digit by digit. I will take every
Ah.
15 digit.
So how will you do that? In what? Where will you put that? Digit by digit?
Because they were
In array we can put
That's the
10.
point. The simple answer. That's what I am saying. Simple. Take the things and put it into a list or array. Okay, that's how it is done. You
And
take
every position will be place value of that.
exactly. That's how. Devashmit also said the same thing, but I just wanted the word array. That you take the positional value one by one and put them into array, because each cell would be storing that particular position value, and arrays are unlimited, right? You can make it as long as much as you want. So
Yeah.
it's not restricted by data type of a particular programming language. So this question is very is quite famous, and you will see that, okay, oh my god, okay, I am using C++ or Java. The largest data type is, let's say, 12 bytes, and I have to work on a number which is 2 to the power 50 or 2 to the power 60 bits long. How can I? 2 to the power 60 digits long. How can I work? So that's why it is asked. Be careful. So you put it into array. Now once you have this array,
arrays are like when we are reading a file, we are reading it one character at a time. So arrays are also like that. When we are pardon?
When we are reading, continue.
So when we are reading like one element, we are not looking at everything else. We are in memory. There is only that one element, right?
Now that's quite a from our perspective of this course, in memory there is only one element. So I would not say in memory, I would put it in this way, that in the loop, whenever you are running the loop, I comma j is only considering or seeing that element, only that I comma j element. But I will not say in the memory only one element is there, because in the memory there are many elements depending upon a concept of spatial locality. So what is spatial locality and temporal locality, and how a cache line is being, there are multiple things which is a part of operating systems or computer organization course, right? So we cannot go into all of that, but
So, if we put it in array, then the first number in that array will correspond to one's digit or the last digit.
in any way you want. So, but you have to write the code accordingly. because you are putting it into an array. After that, what you will do? You will do the multiplication, right? So essentially, you have this first array and this second array. So this is your number first A and this is B. A and B are the two number inputs that you have. Let's say 2 to the power 30 digits long input. And then what you will do? This A and B you will multiply, right? So whatever, in whichever manner you want, you can do it, because the multiplication algorithm you have to write. So if you want to put the first cell as the ones digit, you can do it. Last cell as the ones digit, you can do it. But you have to do the multiplication accordingly. So, by the way, just a minute. So yeah. So anyways, so you can decide that. But now the main point is, this is where the integer multiplication concept comes in, right? How will I do the multiplication? Now this is basically, now I will consider that ones digit is on the right hand side. So this is your ones place, like normal. I mean, normally we do in school level mathematics. So once this rightmost cell is ones place and leftmost cell would be the MSB bit, MSB number digit. So we will do multiplication like this, the normal, like this number with all of this number and put the value, and then this number with all of this number and then put the value, right? Normal cross multiplication. So you have to iterate through these loops on A and B arrays and multiply it. That's where the integer multiplication comes into our discussion. Okay, fine. So this precursor part is not discussed here, but it is very important to know where to use it. Why exactly this notion of integer multiplication is coming? Because normally while coding you will not even think about it. Simply multiply, put into two variables and do the multiplication. But where in practical life you will need it, this part is very important, that where the numbers are beyond your programming language's capacity. So you put it into some data structure, preferably array or list, and then you have to do cross multiplication. Now when you do simple, and then finally at the end of the day you sum it up. So when you do cross multiplication, now we will discuss that in order to do this cross multiplication, when we are dealing with large numbers, we are using arrays and we are doing cross multiplication. And while we are doing this cross multiplication, then how to improve the timing? That's the part where the lecture starts. Once I have reached this part, now I have to improve now the question comes, how to improve the timing.
So one very elementary question. How
Yeah.
many, what is the, I mean, the size of a number which can be stored in a variable in Python?
I don't know in Python, because I don't know the internal implementation. You can check it out. Okay.
I have read, I have seen somewhere that it is infinite and it is internally using C++, but it is a class, not any simple. So it get extended as far you want, as far
Yeah,
your memory allow.
that's the point. But there should be some limit. I don't know. Maybe. I don't know. You
Sir,
have
I
to
have tried very long numbers to store and it get stored. Means 100, 200 digit number get stored.
Correct. So see, that's the point I am telling you from a real life perspective. Python has a lot of internal, because that's why Python is a good language to work with when you are not trying to deal with the intricacies of these subtle things, right? How it is working, how much time is it taking. But
And
when you are
that's why it is slow.
Internally, it may be
But-
taking this same thing, right?
taking a long time, but that's the point. But when you are working on real life softwares, or let's say softwares which particularly work on real-time systems. Real-time systems means you get an input from the real world, you immediately have to respond to that within some deadline. So there are multiple things like that. So one particular example would be your satellite systems, right? So RTOS things are the real-time operating system works over there. So those kind of sensors, actuators, systems where you have to work on real-time data, real-time environment, and there is a deadline for the the stimulus that you get from outside world because of an action, you have to respond to that very fast. In those kind of scenarios, you have to think about the timing. It's very important about how the algorithms that you are using, how even a simple multiplication is happening inside it. And not only at an algorithm level, if you go further down, you have to optimize things at hardware level also. That's where the ASICs come, like application specific integrated circuit. If anyone of you are from electronics background, you might know that depending upon different use cases, you design different embedded systems. So not only at algorithm level, you even go down below to the hardware level. So can you see that how much benefit, how much detail oriented are you getting? And you cannot use a language simple Python or something like that, because that would be a very heavy thing, and internally it would take much more time. So in these kind of real life scenarios, when you are writing code or working on such a project, you have to take care of very elementary things that you wouldn't even think of while working on some other projects, right? So simple multiplication, addition also counts. In those kind of scenarios, these things matter a lot, how you are doing. Okay.
And if we put the two numbers in an array, as you said, for multiplying them, then the result will also be in an array, right? Result will also be.
Yeah. Right. Result, everything would be an array. So you have to write that two arrays are there. Now you are multiplying like normal cross multiplication. So 2, 4, 9, 6, 3. This is one. Each of them are in an array, in an array cell, right? And 1, 0, 0, 2, 4. Let's say this is the second number, and now you multiply 4 with 3, and then you multiply 4 with 6, then you multiply 4 with 9. Accordingly, you will get some number. That number would be put here.
So this kind of algorithm will even allow us to multiply like wild number, like 2 raised to power 250 and 2 raised to power 350.
Exactly. That's the point. That's what I'm saying. So you can do any multiplication or anything, any number, any language you give, any large number you give, I can operate on that. But the point is, at this point our lecture starts. This initial discussion is not there, but this is where the how do we multiply two integers x comma y comes. Because otherwise, why do you need to multiply? Why do you need to think of any of this? Now, since I'm coming into this cross multiplication on arrays, now we have to think, how can I use the timing? How can I optimize the timing? As you can see, because this would take n squared time. This is an array of length n, and let's say this is an array of length, suppose it is m or whatever. So this would take you order m into n time, or if both of them are in terms of same variable, this is basically order n squared time. So that's quadratic time work that you need to do. Why it's n square, by the way? Because as you can see, for every number I have to go through all of
Sir,
them.
what is n? Number of digit?
Number of digit. Okay.
So it will be very less, no? Means maybe we need to, our number of digit will definitely not exist 1000.
Array, the whole point of discussion is where the number of digit exceeds 2 to the power 15, 30, something like that. Why I am discussing all of this then? Right.
It's like we
Oh,
said,
sorry.
we said
I get
that
forget.
on
2 to the power 16 number of digit. Okay, I got it.
Yeah. The whole point of discussion is that when the number is so large, we cannot put it into variable. So,
Yeah.
So it is
Okay.
like not sending Chandrayaan, but sending something like Suryayaan, right? So, and we are
Yeah.
calculating how long it will take to return to Earth.
Exactly. Yeah, so it would be working on very large numbers. So as you can see, the overall time would be order n square, as you can see. Why? Because I hope you can understand it, right? For each value, we have to go through all of them. So for each of these n, I have to go through all this whole n. So order n square time. So therefore, how to solve it? Now I want to improve the time complexity from order n square to something else. How to do that?
Sir,
Yeah.
one small doubt I don't know, but this 1 plus 1 will be 2. Why they are writing 2 zeros from the left second?
Where?
Here
Which
only.
one?
This 1100 multiplied by 1101. At the
Okay.
answer, it should be 1201. But sorry, 121 11100. But they are writing 100 Why?
I am not getting what you are saying. You
It
are
is
telling the
binary,
answer
I
is
think.
wrong.
Means in binary you will replace 2 with 2 zeros.
No, it would be 0, 1, 0, right?
Maybe a calculation mistake, no issues.
Like here 1 plus 1 will be 2. Why they are not including 2? If you sum all the things, then will be 1 plus 1 will
It's
be
not
2.
binary. Okay. No, it's binary. It's binary multiplication. This is 10 base 10 multiplication. This is binary multiplication.
So 1
This
plus
is
1.
based. Now, do
Then
you
how
know
you will
binary?
add 1 plus 1?
Let me tell this. Do you know binary?
No.
Okay, that's the issue. Okay, so you have to know binary. How does binary numbers work? Okay. So that is not a part of discussion in this course, at least, because it would take some time. I would suggest you to just watch some material. It would not take more time. It's a simple thing. Just watch some material on how to do basic binary operations. What are binary numbers and stuffs like that.
Multiplication they did the same way as we do for normal numbers.
It's done in the same way, but the arithmetic rules are different for binary numbers. Okay, so 1 plus 1, when I'm doing 1 plus 1, so binary 0 1 plus, let's say, 0 1. This is binary for 1. Binary for 2 would be not 2. Binary for 2 is 1 0. This is 2 base 10 is equal to 1 0 base 2. Okay, so binary 2 represented in binary is actually 10.
Okay.
Fine. And 10 represented, let's say 10 in decimal is binary. How much? If I write it, it would be 8, and then 4 is 0, and this is 0. This is your 10. Am I right? Okay.
Okay.
Anyway, so just check out how binary numbers work. Fine.
Sir, where can we, means where we use 2 to the power 15 digit?
2 to the power 15, we use numbers larger than 2 to the power 67.
No, number larger than 2 to the power, 100 possible, but digit larger than
digit only. Digit only I am talking about. Numbers with digits, values with number of digits larger than 2 to the power 15, 20, they are obviously, we work with them primarily in astrophysics, right? And secondly is in theoretical mathematics, where you need to work on multiple things. So we run a lot of simulation on proving some theoretical numbers, whether they exist or not, or something like that. So in multiple cases we work with them, and in astrophysics it is used a lot. So, okay, anyways, coming back to the point, now how do we improve the time complexity of this simple cross multiplication that we learned in our school days by using divide and conquer, and so that it reduces to something lesser than n square. So we, as it is divide and conquer, we break the number into two parts, x1 and x0, y1 and y0, right? Simply halving. So whatever, just breaking it into two equal halves. Okay, and then what we will do? It's a simple trick. See, I am writing this, rewriting x, so I need to find this x into y, right? That's what I need. So what I'm doing over here is I'm rewriting x as this thing. x1 into 2 to the power n by 2 plus x0. This is equal to x. Anyone has doubt in that? Why it is equal to x? What is x0? x0 is the lower half of x. As you can see here, x0 is the lower half of x and x1 is the upper half of x. Any doubt in this? How it is x? So simply if I have to...
Sir, did not get how it is breaking, sir.
So this 2 power n by 2 is basically base 2, no, sir?
Yeah, exactly.
If it is base 10 means it will be 10 power n by 2.
Exactly. That's what I am showing now. I have a number 5942. Okay. So 5942. Can I write it like this?
59 into 10 power 2.
Correct. 10 power 2. What should I write?
Yes, sir.
10 power 4 by 2, sir. 2 only.
10 power 2 only.
5900, sir.
Okay. It's fine. So 59 into 10 to the power 2 plus 42. I can write it in this manner. No issues, right?
Yes, correct.
So in binary, if I have a number, that's how it is written in terms of 2. Only thing is, if I write it in any general new number system, so I can write
Sir,
it
you are
as...
switching binary to decimal, sir. Please specify, sir.
No. I am, since this is not understandable, that's why I converted into decimal format. Just forget about this. Tell me this is okay or not.
Yeah,
this
yeah.
decimal thing.
Decimal is okay, but when you are dealing decimal, when you are dealing binary, it get
Oh,
confused.
now okay, forget binary. Now decimal only. So this is 59 into 10 to the power 2 plus
Yes.
42. This is
Yeah.
fine, correct? Okay. Why
Yeah.
10 is coming here? Why I'm writing 10?
It is just place value.
Place
But
value, right?
this is
This,
decimal notation. The number in decimal.
this is
Yes,
the
10.
this is the base. This is what we call in any number system. By the way, in maths, did you guys didn't learn number systems? Hexadecimal, octal. These things are not there in maths or in some
No,
other.
it is
I
not
don't know.
there, but I think there is a one tutorial.
Sir, it is only in 11th, 12th computer science subject, not in mathematics, sir.
No, no. In
In
these degree,
DBMS, you have one
No.
tutorial on binary, sir.
TBMS one tutorial is there that I think I only made earlier.
Yes,
But
yes, sir. Yes, sir.
anyways,
Yeah.
fine. So I would request all of you to watch the some content. If you have the subscription for DBMS course, just watch the tutorial where we have
Sir,
discussed.
we know the basic addition, subtraction, and conversion,
Right?
but
You
not
need to know
multiplication, division.
you need to know number systems. Forget about addition, subtraction. What are number system? What is base of a number system? All those things
Yeah,
should be
base
clear.
is we know, sir.
Right? Okay. So this
Base
is base
2.
only. So right. So if I have to represent 5942 in octal, let's say, sorry, not octal, 9 cannot be there. Let's say 5142. Okay, 5142 is a octal number. Suppose octal. So then I cannot write it in this manner. If I have to write it, how will I write this thing? Same thing.
So
I will write.
we will
One
choose
into
those
8 to the
powers.
power.
8 to the power of 2.
Yeah. So basically, if I break
51 into 8 power 2. This is basically
8 to the power 2
plus
plus,
42.
let's say I break it
Power
down.
2.
I break it down here
8 power
also.
1. 2 power 2 into 8 power 0.
Right. So this is the way if it is in octal number 5142 octal. Okay. So that means in a general scenario, 5 into whatever base it is, base to the power 4 plus 1 into base to the power 3 plus 4 into, sorry, this is 3, this is 2, 4 into base to the power 1 plus 2 into base to the power 0. This is the normal way of representing any number with its place value and with the base to the power the exponent, right? This is how we represent. Now
Yeah.
if it is binary, so this b will be 2. Remove all this b with 2, right? And okay, forget about this. If it is binary, then this will be 2,
1 zeros.
this will be 2. Obviously 542 cannot exist in binary. It will be some number of 1 0
Ones
0
and
and 1
zeros.
only. Yeah, coming to that. But let us suppose for 1 second that suppose somehow this is there. For 5 is there in binary. So what I have to change is I have to change this thing, right? The base has to be
Yes.
changed. That's the point. But those numbers are 5 and all these are not there in binary. So that's why the basic thing is if I have a binary number like this, let's say 1 1 1 0 1 1, right? This is my binary number. And if I have to represent it in a manner, so I will write, let's say 0 1 1 plus 1 1 1 into 2 to the power 3.
3.
Fine. Same thing. Whatever happened in your base 10 system or base 8 system or whatever, any arbitrary base system, same thing is happening in binary. Now, if this is my number, now compare, this is x. So suppose this is x. Fine. And this is x1. And this is x2, x0. Now compare this with this expression.
Yes, sir, got the point. Actually, we previously thought it was base 10, then we are thinking how this is 2 come.
No, it's base 2, okay?
Yeah,
So,
fine, sir.
okay. Fine. So, as you can see here, 2 is there. So, everything we are working on binary number and base 2. So, this is x. Accordingly, this is y. Same concept. And this, therefore, whole thing is x into y. I'm just breaking it down and writing it. Now, if I regroup, so simply regroup, basically do this multiplication. So, x1 2 to the power n2 into this quantity, then into y0, like that. You're simply doing a plus b into c plus d, that kind of thing. So you get this expression, right? Now, how many so what did we gain over here? First thing is x1 into y1 is one multiplication term. This is second multiplication term. This is third multiplication term, and this is fourth multiplication term. Each of these multiplication term is having how many bits? N by 2 bits. But earlier I was doing multiplication on x into y that had n bits. Each of them had n bits. And now each of these multiplication x0, y0, all of them individually have n by 2 bits. Right? So it is multiplying on a lesser length value, lesser length number.
How you are sure that it is n by 2 bits?
I broke up x and y into two parts, right? See this. x1 is with this thing. x0 is this thing. Okay.
Okay.
That's what we did. This is 0. That's, see, this is x0. Last 3 bits is x0. Most significant 3 bits is x1. I'm breaking it into two halves. Okay. Anyways, so we got this 4 multiplication, each with half the number of bits now. So if we now, as you can see, 4 n by 2 bit multiplication. I had earlier only one n bit multiplication. Now I got 4 n by 2 bit multiplication. So what? How will it how? So if I do, so multiplication is normal. So one function is there which is simple multiplication. Give two numbers, it will give you the result by multiplying, cross multiplying. Cross multiplying means this thing, normal school life multiplication. So I have already written a function which will do multiplication. Now what will I pass inside that function? Initially I was passing simple x and y, but that was taking me order n squared time, right? Because this whole thing is n square. But now I have done is I have broken it up into smaller n by 2 bit multiplication, but I got 4 separate multiplication in order, since I broke it down, I got these 4 separate terms. This is actually equal to xy, right? This whole thing would be equal to xy. So now I got these 4 terms. So what I have to do is I have to recursively, every time I have to pass. So I will pass in the same multiplication routine where I passed x into y earlier. Now in the same multiplication routine, I will at first pass x1 into y1, then I will pass x1 into y0, then I will pass this one, and then I will pass this one. And I will collect the result of these 4 multiplication, and then finally I will evaluate this whole expression. Evaluating this expression is very easy, right? It would take you order n time. But I have to do this separate 4 multiplication and collect the result, right? So recursively, what will this look like? It will look like that every time I do that, t of n would be, since I have 4 multiplication, and every time I'm breaking it down into half,
n by 2
plus
t,
sorry, yeah, right, plus n. Why order n? Because in order to do the multiplication, right, you have to do the summations basically at each level. Within each multiplication, you have to make the partial summation, right? So that is corresponding to an n bit summation. Actually, it is order n, not n. It's order n by 2 would be there. Anyways, so this is my recurrence. Now, if I solve it, if you simply go on solving it, I think it is solved in the slide. Yeah, as you can see here, if you simply go on solving this recurrence, 4 multiplications are there, right? So at the end of the day, you again end up with order n squared time. So simple putting x into y also was giving me n squared time. And I broke it down into 4 separate smaller n by 2 bit multiplication and went into all of that trouble. But still it is giving me n by 2 time, n squared time. So I didn't get any benefit from that. So what to do? How next?
That be overhead also with the recursion.
It's a lot of overhead also because we added recursion. So it is actually worse. So what to do now is a very tricky and very elegant solution, and that is we simply do some rearrangement of the terms. And how is that rearrangement working? See, consider this quantity x1 minus x0 into y1 minus y0, just out of the blue. Do not think from where is it coming, just don't think any of that. Consider this quantity x1 minus x0, y1 minus y0. I hope you know what is x1, x0. X1 is the upper half of the x number and x0 is the lower half of the number x, and y1 is upper half of number y, y0 is the lower half of number y. So when I do this thing, I get this expression, right? And what I need to find is x into y. So x into y is basically this expression. So basically, in order to find x into y, the things that I need is x1 y1, x1 y0, x0 y1, and x0 y0. These 4 terms I need. Correct. Now, but the point is, these 4 terms are 4 multiplications.
Sir, but why are we getting this 2 raised to power n by 2 and 2 raised to
Sir,
power?
but how we are dividing in 4 terms? This is okay. But x1 minus x0, what is x1 and x0?
I discussed that, right? x1, x0 are the upper half and lower half.
So we are essentially dividing again, no?
x1 and x0 are the upper and the lower halves of the number x. y1 and y0 are the upper and lower halves of number y.
No, that is okay. But you said that divide and conquer didn't help.
I'm coming to that. It didn't help. So what will we do? That's the next part, right? So now see what happens. So the problem is that I need I need these 4 terms, but the thing is each of this term corresponds to a multiplication, and we saw that it didn't give me any better result, because it gave us n squared time if I try to do this multiplication separately, although they are n by 2 bit, but still it's not giving me any benefit. So what do we do is we have this expression. From where this expression is coming, don't bother about that. It's just an intelligent guess, something that x1 minus x0 into y1 minus y0. Just think it in this manner. How many multiplication is happening in this expression? x1 minus x0 into y1 minus y0. How many multiplication, not subtraction?
4.
2
One,
multiplication.
one.
One.
Only one multiplication is there. This is the whole term, right? This is one binary number. This is one binary number, right? This whole thing is a binary number. x1 minus x0 would be one binary number, and y1 minus y0 would be one binary number, and I'm multiplying. So only one multiplication is there, right? Any doubt in this? Only one multiplication is there, is it? I am not. Can you see any term like this, that x0 into y1 or something? This means a multiplication. Here all of them are discrete terms.
Yeah, got the point, sir.
Right? So all of them are discrete terms, and I have these 2 quantities, only one multiplication is there. But the point is, after doing this multiplication, right, whatever result I get some alpha result, suppose. After doing this multiplication, one multiplication, I get some alpha value. Now that alpha value is equal to this quantity. This is what? This is just the expansion of this term, x1, y1, x1, y0, this basically expansion of this. Now the point is,
Yes,
right, from here, if I subtract, so what we will do now is, see, now consider this expression. Okay, so x1 y1 plus x0 y0 minus this term. Fine. What will it result in? It results in x1 y0 plus x0 y1. Okay. So if I do this, if I simply x1 y1 plus x0 y0 minus this term, then I get the result as this quantity. So if I do x1 y1, right, comma x0 y0, comma x1 minus x0 into y1 minus y0, if these are the 3 multiplications that I do separately, then what are the terms that I am getting from these 3 multiplication? This term is directly x1 y1, this term is directly x0 y0, but by using this term, by using this term, if I write x1 y1, since I have already done x1 y1 separately, right, so I can use x1 y1 plus I have also done x0 y0 separately, so I can use x0 y0, I do not have to do it again, minus this term basically. So suppose this term, right? If I do this, from this what I will gain? I will get x1 y0 plus x0 y1. So I got this x1 y1 x0 y0 and the summation of this thing. Okay, now come back to this point. What did I tell? That we need these 4 things to get the result. This is my ultimate answer for x into y, right? See, observe this quantity. I want to, so basically my motive is I need to get this quantity. Now observe this part. x1 y0 plus x0 y1. See, x1 y0 plus x0 y1, right? And other than this, what was there? x0 y0 was there, x1 y1 was there. Forget about the 2 to the power. 2 to the power n is simply shifting operation, right? So you don't have to worry about 2 to the power n. So x1 y1, x0 y0, and this term. x1 y1, x0 y0, and this term. So by doing 3 multiplication separately, we can get the whole, all the terms, and simply after by adding so from this I can actually frame this expression, right? Since I got all the components of this expression, whatever component is there I got. But here it was looking that I need these 4 separate multiplication terms, but by doing in this manner, by 3 multiplication terms only I got the result. I mean, I can get all the components and I can sum it up and get the result. So earlier we needed 4 multiplication to actually compute the final result of x into y, which is basically this term, this expression. But now I am only doing 3 multiplication and still I can get this term. So how I can get this term? So this x1 y1 x0 y0 I can get directly, right? I did the multiplication. So x1 y1 into 2 to the power n, it can be done. x0 y0 is all anyway.
Sir, you have brute forcefully do this 3 way. So why we cannot do it in 2 way? Means 2 multiplication.
Tell me, how can you do it in 2 multiplication? 2 multiplication, you need x1 y1 x0 y0, both of these would be exhausted. You cannot do any further multiplication to find x1 y0 or y1 x0, something like that.
Okay. No, I am saying ultimate goal is x1 minus x naught and y1 minus y naught.
No, ultimate goal is x into y.
Okay, ultimate goal is x into y, and we are using this x1 minus x naught and y1 minus y naught 2 parts.
Yeah.
So x1 y1 is what you want to calculate.
You don't need to calculate SE. Why? Don't get confused. So, okay, I think I will not address that because these are pretty basic doubt. You should see the lectures, because x1 y1 is simply the numbers. I have broken the number x and y into 2 halves. First upper half is x1, lower half is x0. That's it. Okay. I'm not going to discuss that again.
So basically, divide and conquer, we will gain efficiency if we save the number of
multiplication.
Right. So here we are doing 4. With this trick, we are reducing 4 to 3. That is where the savings is, right? So otherwise, we saw already by breaking and merger type of style, it's not really helping. So we end up spending same time plus overhead. So this is the trick, that instead of doing 4, we are doing 3 in the intermediate steps. Right?
Exactly.
We are getting point. You are reducing the number of multiplication by doing some quick algebra.
Just algebra, yeah, that's it. Nothing else. Simply we are reducing the number of multiplication by doing a rearrangement of the algebraic expression. That's it.
Yes, sir.
The similar thing we have done for calculating GCD, right?
Exactly. Correct. So I got this expression which I needed. See, in order to do x into y, so this is xy. X into y is equal to this whole expression. This is the final thing that I need. Okay. Now x1 y1 is itself I have calculated x1 y1 particularly separately. x0 y0 is also calculated separately. So these two are already there. But I need x1 y0 and x0 y1 now. Now, if I do it separately, then it would be 4 multiplication. Rather than doing that, I have this tricky term and here only one multiplication is happening, and by using this term and putting this term into this expression, I'm getting this internal term, this whole thing, right? So although I need to do some more subtraction and addition, one subtraction here, one subtraction here, 2, then again in order to use it in this expression, again one subtraction over here, one addition over here. So I need to do a few more addition and subtraction. I am agreeing with that, but by using this expression I can get this result, right? And I'm only worried about multiplication now. By the way, why I am only worried about multiplication and not worried about subtraction or addition? The point is, you can tell me in terms of hardware complexity, multiplication is a more time taking process, but not only in terms of hardware. Even if you think, sorry, can you mute? Sorry, whoever, yeah, thanks. So even in terms of simple mathematical understanding, if you do addition of an n bit of 2 n bits number, right? 2 n bit number or n digit number, forget about bits also, 2 n digit numbers are there, we are doing addition. The result would be how many digits at most?
N plus 1.
Correct. N bit, right? So if it is n bit, so n plus 1 bits, n plus 1 digit or n plus 1 bit number would be there. If you do subtraction, same thing, right? N digit would be there. But the thing is, if you do multiplication, then it is actually added. So if 2 n digit numbers are being multiplied, then it would be twice. The result would be twice many digits. So because of this, because the result becomes much larger, and anyway we are dealing with large number of digit, I mean such number which has a large number of numerals, large number of digits. So that's why we are trying to optimize or reduce the number of multiplication. That would be very heavy. But addition subtraction wouldn't matter that much, because anyway this would be taken care of recursively, right, at each level. So at this n values would be changing at every recursion. It wouldn't be as large as, I mean, the ultimate n at every recursive step. So n would be smaller, and at the only towards the end of the algorithm, the n would become very large. But still, that's not an issue, because I am doing more addition and subtraction. So n would still remain n. It would not become twice n. But if I do multiplication, then the numbers would be twice as much large, right? So that's why we are trying to reduce the number of multiplication, even though it we have trade it off with more number of addition and subtraction. I hope why we are doing that is clear. So fine. So now that is done. So by using this 3 multiplication, I am gaining all these values, right? So only thing is now I have to create this expression from these results. So as you can see, x1, y1 and x0, y0 are directly usable. x0, y0 and x1, y1 I can use directly. But this term, how I am getting? I am getting this term by using this expression, right? So basically this would be equal to, now let me write in detail. Suppose x1 is a and x1, y1 is a and x0, y0 is b. Okay, and yeah. Suppose x1, y1 is put into some variable a. In your code, you have particularly divided x and y into 2 halves, x1 and x0, y1 and y0, and now you have passed x1, y1 into the multiplication function separately, and x0, y0 in the next again you call the multiplication function with x0, y0 as the argument. So that's how you got x0, y0 and x1, y1 as 2 results, and you put x1, y1 into a variable and x0, y0 into b variable. Okay, now how will you write x into y? Because our ultimate goal is x into y, right? So x into y would be a into 2 to the power n plus, let's say this x0, y0 would be, I will write here, b, only b. Actually it would be b into, theoretically 2 to the power 0, but let's not write it. B plus a plus b
plus c
minus
x1 minus x0 0. Okay. Fine. That's your answer, Now you see how many multiplications are there? One multiplication, because A itself, here B is one multiplication, because in order to A and B is basically these multiplications, and only one multiplication here. So 3 multiplications. And you got the result x into y. Okay. Now, so what would be the recurrence now? Initially the recurrence was what? Tn equal to 4Tn by 2 plus n. Now the recurrence would be Tn equal to
3Tn by 2.
plus n, right? And because of this 3 and 4, now if you solve this 3 recurrence, right? 3Tn by 2 plus n, if you solve this recurrence, you will see the time is different now.
Log of 3 with base 2.
Correct. So I think that is 1.6, near to 1.6.
1.516 or something like that.
Yeah, anyways, so let me, 1.59, 1.6. Yeah. So your term would be n log 3, so basically n to the power 1.59. Initially it was n square. So we got a somewhat a nice, not very much good, but still kind of a okay optimization. Fine. So now let's go back to the code.
After all this, we have gone from n squared to n, maybe approximately 3 by 2.
Yeah. So code is very simple. As you can see, we have one fast multiply function, and as you see, first we will divide the numbers. I mean, get x1 x0 and y1 y0. As you can see, what we are doing here. How many of you just see these 2 lines and tell me who has doubt in this?
Sir, what is x and y?
X and y are the 2 numbers.
List or number?
No, x and y are 2 binary 2 variables in which binary numbers are stored. 1 0 1 1 0 0 1, something like that. Okay. In this case, okay, let me just address this at first. In this particular code, we are not discussing the main utility which I discussed in the beginning of this session, that you have to, basically you are using integer multiplication in real life when you are putting it into list or array and then working on that. Okay, here we are not doing that. Here it is on simple variable. So the practical utility of using integer multiplication is not discussed in this code. That is only doable when you are using on list or array, because here you don't need it actually, but in that case you will obviously need it.
Sir,
Here
so we are dividing numbers, sir. So dividing number will be same as multiplying 2 numbers.
Whatever it is, I am just telling you that x and y are 2 variables, simple variable in which binary values are stored, binary numbers are stored. Okay, and I am asking you that this bit shifting, these 2 lines which I have highlighted, these 2 lines, whoever has doubt in this 2 line can ask. Are you getting what these 2 lines are doing?
No, sir.
Okay,
Dividing the numbers into 2 halves.
fine, but can you explain how it is done?
Sir,
It should be actually this division. What do you say? Floor division actually.
shall I try, sir?
Yeah, go ahead.
Sir, I would take it, since I was more interested in my decimal system. What I will see is there are some numbers are there, and as we explained that 5942, so we are making into 2 parts. So for first part, that is x into 2 power m. Basically, it is 10 power m, 10
Correct.
power n by 2. 10 power m is n by 2. We will keep it as n by 2 itself. Instead of base 10, here we are using base 2.
Yeah.
So first number we will get right left hand side.
Should it
And
be
for the
floor
right hand
division?
side, for example, last is 5945, 45. 45 basically is nothing but divided by 45. You are dividing by 10 power 2.
Correct.
It will become separated
So
unit
let's
side.
fine. So let me do that, and then again you can continue. So let's say I do this same trick in decimal system, then you will understand. Those of you have doubt. So let's take a number. Let's not take 5945. Let me take another number.
Shouldn't this be floor division? Shouldn't this be floor division?
Yeah. It should be floor division. Okay. So let's take a number. Right. 1678 is one number. 784. 16784 is, suppose one number is there, 16784, and let's add another one. Let's say 9. Now, if this is a number, right, and m is equal to what? N by 2. Yeah. So m means in this case it would be what? N is
3.
basically 6. M is 3. Okay. So if I divide this term 916784, if I divide this term, this is x. Suppose this is x. Suppose, okay, here it's not x because x is in binary number. In the code, x is in binary number, but in my example, let's call it x10. Okay, x10, it's in decimal. I'm only putting an analogy between binary and decimal. In the code, it is in binary. Don't confuse it with the example that I'm giving now. I'm only giving this example to make you understand what this expression is doing.
No, sir. Now, because of this comparison, it is clear.
Right, you got it. So 916784, if I divide it with what? Here 2 is there, right? But I told you, if it since
Because,
it is
yeah.
binary, it is base 2. Now we are in decimal, so I will do that with base 10.
So this algorithm is only for decimal. Sorry.
Binary.
Only for binary.
If you want to change it, all
No,
you have to do is change the base. That's
only
it.
base change.
Okay.
Change the base, right?
So why Sir has taken base 2, we are not understanding, sir, because we are so much in base 10. This can be used in base 10. Later on, we could have explained instead of base 10, we can use base 2 also.
I'm telling you why it is taken in base 2. The reason for that is, as you can see, integer multiplication is a very basic thing, but we are discussing it over here because we are discussing it at a advanced optimization level. So how we want to do it. This actually comes into action when you are writing subroutines for multiplication at the hardware operating system level, where it is done in binary only. Okay, but that part is out of the discussion in this. Within this context, it's not simple algorithm. You can do it with any base. That is fine, but this is practically used at the hardware level when you write optimized multiplication subroutine at electronics level, or let's say not electronics level, I would say at the operating system level, but at operating
No
system
problem,
level,
sir.
right? So that is the
You
idea.
are explaining base
Here,
10.
suppose, sir, here m is 1, then 2 raised to m will be 10, right?
Why m is 1? M is 3, right?
So, no, in this case, m is 3, right? But suppose m is 1, suppose n is 2 and m is 1, then 2 raised to m will be 10, right? Because it is in binary.
Brother, please binary forget right now for some time. Let's focus on this base 10. Sir is explaining, no?
Yeah,
916784.
just see this, no? And we'll come to that. Now, here it is, m is 3. So if I put 3, base 10 to the power 3, same thing here to be binary 2 to the power 3 is there. Would be there. Same thing is happening here. So if I do that, what will I get? What should be the result? Floor, obviously, everything is in floor, okay? Floor division.
784. 916 and 784.
X1 will be 916.
Answer is 916, right? Dividing by 1000.
The second mod is 714.
Correct. So the next is, if I'm doing modulus, so when I'm doing 916784, modulus 10 to the power 3. What does this mean? So when I divide by 10 to the power 3, whatever is the remainder. So remainder would be 784, correct? So by doing modulus, I get 784. By doing simple division, I get the upper half. So by doing simple division, I get upper half. By doing modulus, I get lower half. Now only thing is the base. Now here it is done in binary. That's why base is 2. Here also base is 2. That's the difference.
Why is when we are returning, why are we having this expression 2 raised to power n and then 2 raised to power n by 2?
That is x into y, right? I think I discussed that. X into y. This is the whole thing.
Okay.
X into y. Our main idea is to do multiplication, simple 2-number multiplication. But the thing is, by multiplying x into y, it is taking n square time. So we came into this form of multiplication where we break it down into x1 y0 and where we break it down into x1 x0 and y1 y0, so that it is n by 2 bits. x1 x0 is upper half and lower half of x, y1 y0 is upper half and lower half of y. So if I break it down into half length x1 x0 y1 y0, so I hope that, okay, since each of these term are of half length, therefore it would give me some benefit. But simply doing this multiplication did not give me any benefit. We saw n squared time was used. You can just refer to the earlier part of my discussion. But that's why we came into a new trick of using this out of the blue. We came out of this, we use this expression, and from 4 multiplication we reduced it to 3 multiplication, right? And that's why our now the new way of writing x into y. So this is initially, this is x into y. X into y is equal to this. X into y took n squared time. This also expression took n squared time. That's why we came into this, which is taking me n to the power 1.59 time. Okay, because it uses 3 multiplication. So our end result is this thing. And as you said that why we are writing this term p plus q minus r and all of this. So what is, by the way, what is p? P is x1 y1, right? P is x1 y1. Q is
Our
x0.
example is A. In the example you gave, it's A, sir. A, B.
A, exactly. In my example, no, it is not P, it is A, and it is not Q, it is P. And R, I have not written it in terms of, I mean, I have directly written P, not written in this form. So what you can write here is A plus B is there, right? Minus this is this term. Where this term. X1 minus x0, y1 minus y0 are putting into A and B. And here it is P plus Q minus R, because here I am doing the multiplication of A and B. Right? What is A and B? X1 minus x0, y1 minus y0. So this R means right this term. So that is minus R. So if you go over here, see, this is R. Okay. Fine. Nothing new. Simply doing that and then simply multiplying and returning the result. I hope it should be okay. Okay. Any doubt?
Sir, does Python multiply the
Sir, but you are dividing each time, sir.
Sorry, sir. Let him complete his question. What Python?
Does Python use this algorithm to multiply numbers whenever it does?
Okay. What? No. Most probably not, because it is not needed at this level. This comes into action at the very hardware level, I would say, most of the times. Or if you need to code an algorithm, I mean, if you need to code on such a data which is very large and you need to put it into list or array, then you will need this to improve.
Okay,
right?
Because this was a faster way of multiplying, so I thought maybe the Python is using this algorithm to multiply numbers. Whenever we say A star B, does it use this one? I thought maybe.
Most probably not, but I am not sure. It may use internals. None of us can be sure how it is done. Okay, anyways. But the idea is, let me again address this part very with much stress on that the thing is, this is very much required when you are using numbers so large that you cannot put it into variables. So you put it into arrays or list or whatever, and then you are writing separately. I mean, if you want to multiply, then you have to write separate function to do the multiplication for those arrays. When you are working in such an environment, then you need, and you still want to gain optimization on the code, right? Otherwise, it will take you n squared time. So if you want to optimization on the code, then you come to this Karat-Zub algorithm, right? And then you will do the work. But in this lecture, in these slides, we are not dealing with that exact real life problem where actually this is used. We are simply discussing the core idea of Karat-Zub algorithm. That's why we are not used to a practical situation in which this would be required. Okay, but for your knowledge, it is very important. You should know that in which kind of situation it would be required. Otherwise, why will you use all of this to do simple A into B or X into Y, whatever? You will never use. You will simply learn and write the exam and forget about it. That's the thing. But you will need it. You will need to use this when you are working in such a situation, right? Where you are putting into large arrays And when you are multiplying, if you are working on an array which is, let's say, 2 to the power 30 digits long, I mean, basically the size of the array is 2 to the power 30, and you are multiplying two numbers which are basically 2 to the power 30 digits long. So it would be 2 to the power 60 digit answer. And the multiplication is taking n squared time. Can you imagine how much time it would take? The answer wouldn't come. Your time limit would be exceeded. That is the point. That's why it is asked in many coding interview questions and coding question. I mean, this coding exams. Keep that thing in mind. Put it into arrays and then write simple cross multiplication code. But it would take you n squared time, so it would work on smaller input, but larger input it wouldn't work. In such a scenario, you will use Karatsev algorithm on the arrays. Okay, obviously, what would change? Everything would remain same. These things would remain same. This would remain same. Only thing that would change is this part, because here you are simply, since x and y are numbers, so you can simply use division to separate them. But if they are array, actually it is easier. You see, simply have to run a loop and separate it, or basically you can split it. If it is a list in Python, you can simply split the upper half, put it into x1, split the lower half, put it into x0, and x1, x0 would be two separate lists, right? And then repeat the same steps, right? Nothing else would change. Fine.
Sir, is there no operator, bit operator in Python?
The bit operator must be there.
So why you are not using this? This division is actually, I think, taking much more time.
Bit operator does on bit by bit. We are not doing bitwise calculation. That would be taken care of.
So that's why dividing that 916784 by 10 to the power 3 will take very long time, no? Means for longer numbers.
No. See, when I am doing it for x by 2 to the power m, let's say here, you said bit operation. When I am doing x by 2 to the power m, here the division would be happening in the bitwise operation.
Why?
At the binary level, when you are actually operating, every division, every multiplication would be done actually by bit operator only at the bottom level. But you don't need to worry about that.
Okay, so it will not do our traditional division algorithms or something.
The decimal number doesn't exist in computers, right? So at the end of the day, it would only do on bitwise operation only. Everything
No,
that
I was thinking like that suppose there is decimal number 5 this 916784. So if you want to divide by 7 or divide by 10, the computer will take almost same time. But if we use bit operator, it will just shift by 3 units. Means
see,
the division.
if you are
So division will be
okay, but
very
if you are
fast.
dividing, if you are doing something by dividing something by 10, then shifting doesn't work. If you are dividing by 2 in binary, then only shift will work.
Yes, sir. That what I'm saying, sir. So dividing by 2 or dividing by 100 will take sorry, dividing by 2 and dividing by 3 will take different time.
Oh, but again, see, no, it's not correct to say bit operation will work on binary numbers, right? When you are saying dividing by 3, you are not working on binary numbers. I think all of this confusion is coming because you guys are not very much familiar with binary numbers and all. So I would suggest you to.
I'm saying, sir, here you are using divide operator.
Yeah.
So divide operator will not care what is left and right. It will do its algorithm. So if we are dividing by
You
2 or 3.
You want to say something like this, right?
Yes, sir. Means shifting a bit is very easier task.
Okay. Yeah. So that is fine. That is fine. That you can do. I mean, I don't know whether this shift operator is directly there in Python or not. If it is not there, then we cannot do. If it is there, you can use. This is shift operator, left shift operator used in C++. This is right shift operator used in C++. I don't know whether bitwise shift operator is there in Python. If it is there, then you should use it for division or multiplication. Okay. But I don't know. So you have to check it out. Whoever can, if someone knows about it, you can comment. Yeah. But forget about, because we don't need to worry about that. Yeah, that would be a better, I mean, a little bit more optimization from a timing perspective, but it wouldn't be as fast as, I mean, it wouldn't affect you asymptotically, right? Some scalar quantity of time would be saved, that's for sure, because shift operations are better. as you rightly pointed out. Anyway, so this is done. Next thing is, okay, I will come to this later because this will take more time. This is quick select. Okay, coming back to the quick short discussion. Can someone tell me what was the partition algorithm doing? Quickly.
The pivot.
Because dividing the array according to the pivot into the numbers which are less than the pivot and numbers which are more than the pivot.
Okay, so let's say I have a number here, and let's say whatever is here, let's say the length of it is m. Fine. So this is what the partition algorithm does. Basically, it will take a pivot and it would place the pivot at its proper position in the array, right? And whatever would be on the left hand side of the pivot would be numbers which are smaller than the pivot element. So these are lesser than pivot and these are larger than pivot. This is what partition algorithm does. Now we are dealing with a new question. The question is, I have to find the kth largest number or kth smallest number. As of now, we will discuss the kth smallest number. Kth smallest number from a list. Okay. How much time will it take? How can you do it?
So naive way will be like we will do it in ascending order. Then the kth position will be the kth smallest.
Correct.
From
No.
zero.
Traversing a list, we can find the smallest number, no?
Kth smallest.
Okay, so we need to sort n log n.
Right. So as the answer was already given, so it would take you order n log n time. Now I want to do it in a better way. So how to do that? So here we can use the partition algorithm. See, partition is placing a particular element at its proper position, and all the element before that would be less and all the element after that would be larger. That means whatever element is present inside the yellow portion, that is on the left subarray, right? This yellow colored part, those elements would not go outside the yellow colored part. Even if you repeat the partition algorithm some n number of times, all the element present inside the yellow part would rearrange themselves within the yellow part only, but they will be there only. They wouldn't move out. Accordingly, the same thing, all the element present inside this green part, let me color it, they would also stay within the green part only. They would not move out, right? Because this is the speciality of partition algorithm, because it places all the smaller element on left side and all the larger on right side. So I can assure you that nothing from the left side will move to the right side and vice versa. It will not happen. If that is the case, if I run partition algorithm once, right, and I place a particular pivot at a place, I can say that and I want to find the kth smallest number. Can you see what I can say in this kind of situation? I can say that if, let's say, this m, right, I have m numbers which is ahead of this pivot. If m is greater than equal to k, and I want the kth smallest number. What can I say? Any conclusion?
It will be in the
It
yellow
will be
part.
on the left side of it will be in the left side of the pivot
Correct.
or yellow color.
Right? I can guarantee that. Why? Because first thing is smallest. So all smaller numbers are on the yellow part. And I can see that I have m number of smaller numbers, right? Then the pivot. Wherever the pivot is, I don't worry about that. That what is the pivot, that also I don't care. But I can guarantee that all the elements which are lesser than the pivot. So the m small elements are there on the left hand side of pivot, and m is larger than k. So if I want the third smallest element, and I have, let's say, 8 small elements of the array at one in the yellow part, then obviously I can guarantee that out of those 8 small elements, the third smallest element would obviously be present there. So that's why it will be in yellow part. That's what I can guarantee. Okay. Now, if m is less than k, not equal to,
It will be the right side, the green part.
correct.
Either it could be the pivot or it could be the green part.
Yeah, m less than or equal to k.
Um, is it so?
If m equal to k plus
Okay.
correct.
So this is the whole situation. Now, the thing is, as you can guess now, because this m would, I mean, the pivot is chosen randomly. I'm sorry, not randomly. Maybe pivot is chosen in some sequence or whatever order you want to do it, and then it is repeated. Now we will simply use the quick shot technique as it is. Only thing is, these three would change. These three conditions were not there in quick shot. So what was the quick shot? Quick shot would look something like this, right? We wouldn't care about condition. Simply we would call quick shot, and we will pass whatever was required. And the so let's say you're beginning to k, you will pass, and then again call quick shot on whatever parameter, then k plus 1 to end, right? And above it you had partition.
Now we will be doing only for the 1/2 now, sir.
Exactly.
Second half not required
Correct.
according to the condition.
Correct.
So it will become
Only one part we will go. Either we go left or right, or simply return the pivot, because that is the element. So
yeah.
this three condition would be added in the quick shot code, so that we get that particular element. Okay. Now
Or
let's,
m plus 1 equal to k, na? It will be pivot. M plus 1.
oh, sorry. Yeah, sorry. Fine. So if I go to this part, by the way, so even if I do it in this manner, right? Simple quick shot, I will return so this will give me the kth smallest element. How much time will it take?
Quick shot itself take n log n.
Quick shot takes n log n.
By 2.
So the best case is
N square. Worst case is n square. Average case is n log n, and best case is
Always worst case. We will always deal with worst case. So worst
case is n square.
So this algorithm will also take n square then, because it is same as quick shot. Nothing will change. Only these three conditions would be added. Right? So this will change. Instead of the right hand part, we will write the left hand part.
So it's better to have kn time complexity by finding out the smallest each time.
Quick select, just a second. Let me call it from anyways. So Yeah, what was I asking? Sorry, I kind of got confused.
Time
What
complexity.
is the time complexity?
Time complexity. So time complexity would be what? Order n square, because this pivot, again, everything depends on the pivot element. So if my pivot element is always the last one, if my pivot is chosen in such a manner that I always end up with this last one, then there would be no yellow list. Everything would be green list. Correct? So again, we will run into the same problem. If everything is green list, that every iteration only the right hand part is there and no left hand part is there. So that means I am going through essentially one by one all the element. I am not eliminating any half, or may not be half, maybe some element, some x number of element, but basically I'm not eliminating some element. At every level I'm considering all the element. So I did not gain any benefit. So again, it's the same issue that we faced in Quickshot, because it is the same code. Only difference is, instead of these 3 lines, I will write these 3 lines. Not also partition. These 2 lines will change with these 3 lines. That's it. But the problem is, it still remains the complexity is n square. So let's still at least go to the code and see the code once. Then we will come back to the solution for this. As you can see over here, I have this condition as we discussed. If you see the code here, it is exactly, it's the same as Quickshot code, quick select. Now the same as Quickshot. Everything is same. Only difference is in this recursive calls. Okay. As you can see, I already told, if it is less, one important point, please keep this thing in mind. This is an error in the slide. Here we are telling that in all the places, I think we are using the kth largest element. Okay. In the discussion over here, we are telling that we are with the code and everything, with all the condition, we are trying to find the kth largest element. But it's not the case, right? I mean, keep this thing in mind. We are in the code, I think in the lecture, sir has said kth largest element, but we are not doing that. We are finding actually the kth smallest element.
Yes.
Okay, so like here it is written kth largest.
If you want to know the largest, then you have to keep the yellow portion as the larger numbers, and green portion as the smaller numbers.
Correct. Okay. Yeah. So that you can do. I mean, that is very easy. Only thing is, I want to address this, because this is not kth largest, this kth smallest. That's an error. Okay. So keep that thing in mind. The code and everything in slide, the conditions that are there in the slide, these cases are everything in accordance to finding kth smallest element, not kth largest element. But finding the largest is not that difficult. You just have to revert the idea. I mean, the array and all.
Science.
Sir, lecture will not be updated? Means it has been more than 1 or 2 years.
I think it would be annotated, but I don't know. I think we sent the request already. I don't know whether it is yet annotated or not. But yeah.
I'm
Anyways,
not saying annotated. I am saying updated. Means
no,
will
most
new
probably not.
lecture will not come
No,
in future?
no, 99% not. Okay, 99%. But yeah.
The concept is not changing, right? Only a edit is being made, so might as well just annotate.
Yeah, that's what I said. Annotation would happen. I already told them. I think it's not yet done, but again, I will now put some stress on the topic. So hopefully in the next run it would be annotated. So I think here you can see the 3 conditions that I discussed. If it is lesser, you part the lower half. If it is equal to, you return, or if it is more, okay. So I think I didn't mention this. If you are trying to go on the right hand side, right? If you are going on the right subpart, so you have to just make a little change, right? This is the change that you have to make. Why? Let us come to the, I think I kind of forgot that. This will not be correct. See, if I'm decided, that is basically this condition holds, right? If m is less than k, that means I have to search on the green subpart. So when I'm trying to search on the green subpart, I mean, what was the parameter of the function? I will, in the quick select function, whatever array and everything I will pass, one parameter would be k, right? K means what? K means the kth smallest element. That's what I need to search. So when I will, this is again recursion. This will also happen by recursion call only, as I've written here. It would again be a simple recursive call, just like quicksort. But here, when I write K, should I write K or should I write something else? That's the point.
K minus M minus N.
Correct. Because when I'm trying to search the kth smallest element of this whole array, but I'm going on the green part, what does that means? I have ignored all these elements which are present here, including the pivot, right? So if something is kth smallest here, therefore I have to cater for all these m+1 elements. I need to remove those m+1 element from K, and then I will find the kth smallest element. So when you are going on the right hand side, you need to remove the leftovers that you are not considering on the left hand side. So that's why this condition has changed now.
So basically, when you go to the right side, you have already eliminated m+1. So
Exactly.
you subtract m+1 from the K. So
Exactly.
then the solution becomes, the same question, but now you have to ask
on a different, let's say, different coordinate.
Yeah, that's a
Exactly.
good one. Yeah.
Sir, one point I am thinking, sir. Suppose there are 20 elements and we need to find the fifth smallest element. So we will
Okay.
do this procedure. But suppose we need to find 18th smallest number. So instead of going smallest, we can go largest second or third.
If you obviously will do that, but the point is, when you are writing code, you are writing code for a general problem, general question, right? It doesn't. So what I'm trying to say is, when you are writing the code in the software, some software you are writing on, in that software, it needs this utility to find kth smallest element. So you would always write the code for kth smallest element. What is the value of k? You don't know. That would be given at runtime by the user, whoever is using it. So if he gives 19th smallest element in a 20 length data set, then it's up to his intelligence to give it in that manner. So, but obviously, if you are writing it statically, so that means you have all the data and everything. So obviously, 20 elements are there. You need to find the 19th smallest element. So that is basically the second largest element. So you write the code for second largest element. But the point
But
is,
that doesn't make difference, no, sir. Whether it is second largest or the 19 smallest.
time complexity remains same. Correct. So
Time complexity remains same because it's not a sorted list. It is unsorted list. So where is the second one? Where is the 18th one? We don't know.
Exactly. Doesn't matter. So anyway, the time complexity of both these things will remain same. But asymptotically it will remain same. But normally when we calculate the time, it would be better to go for largest, because then the element would be present on the left subarray. If you are treating it the kth largest element and considering the left subarray having the larger numbers, then it would terminate in
No,
the
it
left
depends on
subarray.
the pivot also, no, sir.
That's what I'm saying. If you are, depends on the implementation, depends on the pivot, whatever. But okay, no need to go into so much of trouble, because anyway it would be asymptotically same. But fine. Anyway, so this is done, right? Any doubt in this? Why these three conditions are happening and all of that? Okay. So anyway, it is taking n squared time, because again, if you get the pivot as the terminal position, just like quicksort, because it is quicksort, everything here is quicksort basically. Till this point, it is quicksort. Only these three conditions are different, right? So it will not give you any benefit. As you can see, it will still be n squared time. And this is the case corresponding to the position where the pivot is at the terminal. So I told you that either the yellow list will only be there or the green list will only be there. If the pivot is at the left hand side, then only the green list will be there. If the pivot is on the right hand side, right hand extreme, only the yellow list will be there. So Tn minus 1 plus n. Fine. Now to address this question, now buckle up. This is the most interesting part. And this will solve all the problems of quicksort that we have seen since our week 3 or week 2. And this is median of median. Okay. So tell me one thing, that do we need the exact middle to get order n log n time? I mean, so if you
No,
have
we can approximate also.
an approximate, right? Why? Because essentially the n log n is n log some base n. Now this base n, this base b depends upon whether your array is half or 1/3 or 1/8 or whatever, right? So in merge sort, this base b would be equal to 2, because in merge sort I am exactly dividing into 2 equal halves. So, but in whenever I'm putting order outside of this base b becomes irrelevant, right? Because in order asymptotic analysis, our constant doesn't matter. So that's how basically this turns to n log something, some whatever you can call it. Let's say it doesn't matter. It can be anything, and then n. I can ignore the base. Correct. Why? By the way, I hope that is clear, right? Because this will be a constant. N log bn is basically equal to n log, let's say, en by log b base e, right? So log b basically would be a constant, so you can take that out. But anyways, what I'm trying to say is, when we put order, we don't think about the constants, and because of that, it doesn't matter whether I'm exactly halving the list or I am doing, let's say, 1/3 of the list or whatever. It doesn't matter as long as it is not the terminal element. It should be some
Sir,
fraction.
log base 2 and log base 10 both will be asymptotically same.
Yes, anything log base anything would be asymptotically log only, because that's what I said. Log base 4, let's say, some x. Okay, this is basically what log, if the natural log, I mean ln x divided by log 4 natural log. Now basically this is your constant term. So this
Okay, so we get c times
log 4,
n.
right? So this is whole thing is a constant. So that's why this is a constant. If you put an order over here, then this whole constant gets out.
It is just a change of base. In fact, there was a question on the quiz one actually in the Mercer. Typically, instead of splitting into 2 parts, if we did actually 3.
Three parts, exactly.
It's actually a question in the quiz one. So
Yeah.
the order was actually mentioned. So no change actually from complexity.
Exactly. Yeah. So since the base doesn't matter, therefore I don't care whether I get 1/3 of the array or 2/3 of the array, or it is exactly half, as long as it is in some ratio. It should not be terminal element. If it is terminal element, either on the left extreme element or right extreme element, then quick sort and quick select, both of this algorithm will give me n squared time. So what have we done till now? Our main idea was to select kth smallest element. In order to do that, we use the partition algorithm. And after doing the partition algorithm, we see that still the time is not improving, because even though, I mean, I need not, I mean, so basically, even normally if I used without any partition or anything, I could have sorted it and got it in n log n time. But now I have actually done partition and use the quick sort method with some 3 conditions and all of that, but still it is giving me order n squared time. So in order to improve that, we will learn this concept of median and median of medians. And our main idea is, I just need to have a number which is somewhere near to the middle. I don't, or in some ratio, it need not be the exact middle, but it should be somewhere. It should not be the terminal elements. That's the whole point. Now for that, what we will do. So quite simple. Let me give you an example. So what we will do is, we will give me some numbers. Okay, tell me some random numbers. 15 numbers I need. Let's say 3, 9, 22, 6. Give some numbers, man. No one is telling me anything now.
8, 16, 99,
56. All roll numbers you can tell.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
24.
14 are already come. 72. 14 already come, sir. So double time, no problem.
No problem, but let's not do it now.
4.
60.
3 is all.
Right? 4.
11.
16. Let's keep it at that. Okay, so what we will do now is we will break it down into chunks of or blocks of 5. So consider this one, then this one, and 60 is left alone. Okay, so fine. Now I will find the median of this term, exact median. So how to find median? Sort it, right? And then find the n by 2th term. So if I sort it, what will be the answer? 6,
9,
3, 3, 6, 12. Sorry, 3, 6, 9.
9,
12.
12, 22. So 9 is
So,
median.
okay, fine. So just to
9.
display
Here
that.
it will be 16, 14. 14 is the median.
16 is the median.
8, 14, 16.
8, 14, 16. 8, 14, 16. 24, 32, 43.
43 is the median.
Directly take 60.
60.
If I had two terms, let's say 60 and 4, right? So I would take, I mean, simply take 4 and 60, sort it. So after that, I'm considering the upper half. So you can consider 60 as whatever. So basically consider one of the terms. I mean, if there are 3 terms, find n by 2. Basically sort it and then n by 2. So this is what I do. Okay, 4 numbers I got. Again, find the median.
43.
9, 16, 43, 60. Okay. So 43 is your median of median. Where is 43, by the way? Yeah. Fine. Now tell me the time. How much time did it take to calculate this 9 in asymptotically? I mean, in asymptotic notation, I want.
So here we split into 5, we blocks of k.
We will always split into blocks of 5.
N log n.
Yeah.
No, just answer me that asymptotically, how much time did it take to find 9? Just for 9. Just for this subarray.
Sir, it is
n by 5.
Order n.
n by 5. No, not n by 5. N by 5 log n by 5.
Constant.
Sure.
N by 5, n by 5 variable, n
What
by
is-
3 variable we have
5
taken.
log n by 5.
Constant type, sir. 5 log 5, which is constant.
Correct. It is constant. Why is it constant?
5 log 5.
Correct. The thing is, what is n here? Where is the concept of n coming? I'm taking a subarray of 5 length, and
Sir, we are dividing in.
that is separate.
5.
I'm not asking that. I'm not asking
So
about the dividing.
for this subarray, n is 5 and log n is 5. So 5 log 5.
Yeah. The point is, I'm just asking. That's why I encircled it. I'm asking that how much time did it take to find the median 9 for particularly this subarray? Okay, particularly for this subarray, it took order 1 time, because since it is a fixed size subarray, there is no question of n. So for each of these, finding the median will take a constant time. Okay, so the whole process is always constant time. Only thing is the time would be taken for dividing the larger array into blocks of 5 units. That's where the time will come. Okay, so I will so if I write it in the form of a code, what I'm trying to do is, I have a large sub array or list. I am breaking it down into chunks of 5, and I am selecting the median of those each of those sub arrays. That process of selecting the median of each of those sub array is a constant time work, because although I'm sorting, I'm taking the n by 2, whatever I'm doing, but I'm doing it on a array of size 5. Since it is a constant size array, therefore the time would be constant, even for sorting and everything. So the time in terms of n or input size will only come into action when I am dividing the n, the large array, into smaller 5 blocks sub-arrays, right? So how much will that time be? So basically, how much will be the total time to find 43? So in order to answer that, let us go to the code one. So this is your median of median code. As you can see here, see this part first. At first, I will run a loop, right? And each time I will do it for I plus 5. I mean, I'm splitting it from the first I to I plus 5. I will increase, and then I will sort it and append the, I mean, the n by 2th term. I mean, 5 by 2th, that is 2th term. I will add that. And again it will increase by 5 unit. It is incrementing, right? So again in the next iteration it will go for the next block of 5 element. That's what we are doing, and putting it into a list M, right? So I discussed over here, this is your list M, right? In the second level, or if we had more numbers, then it might grow up to 3rd level, 4th level, like that, right? So whatever is, unless and until I mean, I can just go down this tree like structure of 5 elements. 5 elements I chose. Let's say I had total, let's say I had total 60 elements, right? So initially n was 60. How many element will I get? 12 element I will get. 12 medians I will get in the second iteration. From the second iteration, if I again take 5, so I will get three numbers exactly. So like I will continue going on like this until and unless I end up in one number. Correct. So that's why this loop is doing the same thing, and recursively calling median of median again on the next level. So this is on the next level, and at some point you need a base condition, right? So when will it end? When the length is less than 5. So basically, as I said, if 60 elements are there, first iteration would happen, first recursion would happen, then I get 12 element and I store them into M. Now with this M, 12 elements will be executed. As you can see, M is passed in median of median. In the second recursive call, I will get from 12 to 3 elements, and in the third recursive call, from when I with, so 12 elements and then 3 element, initially I got 60 elements, and then when I get to 3 element, then the base condition would get satisfied, it is less than 5. So I will just sort the 3 element and return the middle one. So that's where you will get 43, or I mean, sorry, not 40, the median element. Fine. So this is the whole code. Now if you see the time complexity, this is where the loop is running, right? All this is constant time, right? This is also constant time. This loop is running. This is what? How much time will this loop take?
N
N by 5. So that basically means order n.
Yes.
Yeah. Now if you go to the, yeah, this is the recurrence relation for your median of median. That is, every time you are dividing by 5, and inside each of the iteration you have that loop, right? The order n by 5 loop that I discussed. So that was there. So I'm removing the order. I think I discussed that in solving recurrence relation, we remove the order and write n. So this is the recurrence relation for median of median. I hope it is okay, right? Why it is? Because at every iteration you are dividing by 5, so n by 5 will be there, and order n time is taken by the loop. So if you just solve it, I think it is solved already. Right? So you can solve it. Okay, let me solve it only. It will be order n only. So Tn by 5. Next thing would be T n by 5 square plus n by 5 plus n. Dot dot dot. At some level it will T n by 5 to the power k plus n by 5 to the power k minus 1 plus dot 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 plus n. And when your basically your n by 5 to the power k equal to 1, that is n equal to 5 to the power k, or k equal to log n base 5. So if k is log n base 5, so t of 1 plus n by 5 to the power k log n base 5 minus 1 plus dot 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 plus n. So this will be what? Plus n by n to the power so let me write one term over here. Five to the power log n base 5 minus 2 plus dot 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 plus n. I think it is log n by 5, right? Minus 1. 1 minus 1 is 0. Anything to the power 0 is 1. Just check. So t of what? Dot dot dot. Okay. So equal to t of 1 is constant plus how many times you did this?
Log n with base 5.
Just a second. I think a GP term should come. Did I make a mistake? Okay, 5 to the power k plus n by 5 to the power k minus 1.
Sir, all these terms are of n only, no? So if the complexity will be in n only, no? The complexity will be n only, no? Because all these terms are of n only. N by something, n by something.
Yeah, that is fine. So first would be n, then it would be n by 5, then it would be n by 5 square. Like it will grow, and at the end of the day, it would be 1.
Sir, outside, actually the term n, you are adding, if you take n common, then 1 by 5 plus 1 by 5 square, and like that.
I did not write that. Okay, sorry, wait.
Yeah.
This would be actually, first it would be n, then it would be n by 5, right? In the next iteration, it would be what? N by 5 to the power, whatever k was, minus 1. So here k would be 3, and therefore 3 minus 1, it would be 2.
Right.
Plus n by 5 to the power 3 plus dot dot dot. At one level, it would be n by 5 to the power k, log n base k, right? At the kth level. Now at the kth level, it is log n base k, and k is, if I just move it up.
Sir, actually k is log of n with base 5.
N by n it will come, sir, last one, because
Correct.
k power log
K
n.
equal to n. So k equal to log n. So just a second. So this becomes 5 to the power k, which essentially means 5 to the power log n.
Correct. So it's order 1 in the end.
Yeah, 5 to the power log n. Now this is base 5. So again, if I solve it, this n comes down, n to the power log 5 base 5. Okay, so then this 5 becomes 1. That means n cancels. So this is the thing. So at the end of the day, I get 1, which is essentially n by, n to the power 0 or anything. like that. So this basically I need to, so this is the termination plus T1 would be here. I kind of missed, I think, earlier one term.
So it's a sum of a GP with
Sum of a
number of
GP
elements. Number of elements are let's say k, where k is log n, and our common ratio is 1 by 5. That's it.
whole to the power number of elements. Here the number of elements is what? Log n. Okay, and the initial term would be, since I am dividing
N.
by 5, n. Correct? Okay, now solve it.
4n by 5.
Log n base 5, right?
5n by 4 into.
So now you see, this is 1 to the power 1 by 5 to the power log n, or I can write it as 1 to the power log n, doesn't matter, 5 to the power log n, n.
It is equivalent of 5 to the power minus 1 times log n.
Log n base 5, I'm showing you, right?
Yes, sir.
And divided by, I'm ignoring the constant, but let's say 5. So this is the next thing, which is essentially equal to
5 by 4 is a constant term.
n minus, this n can come down here and 5 will go up here. So again n to the power 1, right? So n cancels. Right, which is basically, if you, this is constant, this is also constant, so order n. Okay, so your median of median at the end of the day would take you order n time. So let's go over here. This whole process is order n. Okay, now so we got a number which is somewhere in the middle. Now how much will be it in the middle? That notion is given by this diagram. It's just 5 numbers that I've chosen. These are the 5 numbers, right? In the first half, this is the first subarray, and this yellow number is the middle one, median for that number. Likewise, I have again these are the separate 5 group numbers, and each one has their own median. Okay, now if this is the way it is, again each of these yellow numbers, this is basically the M list, which I had. Okay, so if I go over here, as you see that I have this 9, 9, 16, 43, 60. This is the M list. So this 9, 16, 43, 60 is the second level of medians, right? And first level of medians is these ones. So this corresponds to, in the diagram, these are the 5 elements, and each yellow color means corresponds to the second level of the median. Okay, now from the second level yellow, these all the yellow elements, the second level median, I am finding the third level median, which is this one. This is basically 43. I mean, in our example, the 43 corresponds to this blue colored box, third level median. Now, this is a pictorial representation of how the numbers would visually look like if you arrange them. The beauty is I can always guarantee that in this setup, see, observe one thing. Let's say these 2 numbers, okay? These 2 numbers are smaller than the yellow, smaller than this number, right? Because these 2 numbers are above the yellow. So these 2 number is smaller than this number. Likewise, this 2 number is smaller than this number. This 2 number is smaller than this number. If this is the way it is, then I can say all these, I can say that all these numbers,
Less than blue.
yeah, are lesser than the blue number, and all these numbers is larger than the, I mean, this deep blue number. So I can always guarantee that. In fact, not only that, I can also say, I can also incorporate this yellow color as well, right? Because this is anyway less. So yeah. So all these numbers are basically lesser than the blue colored number. So when I get a median of median, I can always guarantee all the red numbers would be lesser than the blue number. And how many now I only have to find out that how many red are there. So suppose this total number of this whole number of elements was n, right? So if all of these elements together are n, what would be the number of elements that is incorporated into this red color? Can someone tell me that? Just simply do
n by 2 into 3 by 5.
n by 2 into 3 by 5, correct. Why? Because first of all, I am taking the half, therefore n by 2, right? Half, and in this half, right, you basically taking the half, and within this half, I am only considering 3 out of the 5 numbers that I have. These are 5 at each level, but I am only considering the top 3, which belongs to the red color. So that's why n by 2 into 3 by 5, which is 3n by 10. Okay, so now I can guarantee, therefore, by using median of median, always 3n by 10 elements would be there, which is lesser than the median element. If I use, a block of 5 elements, right? 5 numbers. If I use separate, more than or less than 5. If you use less than 5, it will not work. If you use more than 5, it will work, but the ratios would be different. Fine. Everything is same, only difference is in the quick.
If how it will vary if we vary the 5 number 4, 10?
The ratio would be different, right? This 5 by 10, maybe it would be something else. But why do you care? Because at the end of the day, asymptotically logarithm case doesn't matter. So whatever it is, it would be n log n only. Okay. So so it is simple, the normal quick short code. Only thing is we are calling this median of median function. It was not there earlier, right? Here now we are using the median of median to select the pivot element. So the pivot would be a number which is located somewhere in the middle, towards the middle, may not be exactly in the middle, but towards the middle. And that's why we will always get n log n time. And this step will take order n time separately. Median of median takes order n time, but it is having parallelly, right? So basically your time complexity would be whatever was for quick short, Tn equal to, in this case it is different, T of, what was the number? 3n by 10, right? 3n by 10. 3n by 10 plus T of whatever is the leftover number, 7n by, why I'm looking, sorry, 7n by 10. Okay, plus for the partition algorithm. For partition algorithm, order n.
Or 7n, right? 3n or 7n, right?
Plus, not in recursion, we always consider all the possibilities, right?
But
What are
we are either traversing the lower
no,
segment or the
this is for quick short I am talking about, not quick select. Okay. For quick short, it would be 3n by 10 plus T7n by 10. For quick select, it will be OR, any one of them. Whichever side we go, depending upon these 3 conditions. So for quick short, it will be, okay, so if you don't want to get confused, so for quick select, it would be OR, as you said. Not OR actually, what we do is the one which takes more time. So I will write max.
Max of.
Correct. Because I am considering asymptotic complexity, we should also always consider max. Okay. Max of this plus order n, this order n is first partition. Plus another order n. Why? For median of median. But this doesn't matter because anyway this will take more time. Okay. So in case of quick short, this comma and max would be removed and it will a plus will come. In quick select, I am only going on one of the parts, therefore it will be like this. Fine. So that's it. This is the difference.
To solve it, we can just take.
No, you cannot solve this max part. Okay. I mean, you can solve it. You can solve it, obviously. I mean,
Here it will be 3n by 10, na? Instead of 3m by 10, because m is considered to be the length of the lower.
yeah, exactly. Fine. So
Because we're doing kth smallest, that's why.
kth smallest. Keep that thing in mind. It's written kth largest. It's wrong, huh?
Yeah, we always think kth smallest. That's all.
But sir, max of n by 10 and tn 7 by n by 10 always will be t of 7n by 10 only, no? Max of tn by 10 and t 7n by 10 will always be t 7n by 10 only, no?
Okay, so let's discuss it in this manner. 3m by 10 is what? Let me write it in this manner. M by 10 by 3. Right? Okay. T of n by 3.
So n m is the length of the lower segment. So hello.
What are you saying?
M is the length of the lower segment, but we just discussed that it is Tn by 10, na? N which is the total number of elements.
Lower, just a second, lower segment, but just a minute.
M is the length of the lower segment. It should be Tn by 10, na?
It should be n by 10. It should be n by 10 only. Because we don't know whether it would be always be the lower one or not lower segment. I think it is lower variable it is talking about. Is lower getting modified?
Lower is the length of the lower segment, sir. Lower is the length of the lower segment.
Let me just check once. Where is lower defined here?
Lower is the pointer which is pointing to the end of the lower segment.
Before the plus 1. L plus 1.
Before the pivot.
Yeah. It should be the total elements then only. Okay. But anyways, so let me write it in this manner only. Now as of I'm trying to address something else. As you said, it will always be 7m by 10 that point. So suppose forget about m and n, just answer this. 10 by 7 max. Now what is, so when I'm writing max of this quantity and tm10 by 3 comma tm10 by 7, what is this? What does this max represent? So when I'm finding max of what are we finding? Can you tell me? What does this t represent?
So every time here in the first case you're dividing into whatever 10 by 3 unit. The other one you are dividing by much smaller. So you're partitioning basically.
Correct.
So in the first term you're partitioning into more number of units, whereas in the second one you're partitioning into lower number of units. That's the way to look at it.
Correct. So then in the first case I'm dividing m by 10 by 3. So basically, so that means so m would be m, and I'm dividing m by only 10 by 3, and here I am dividing m by 10 by 7.
So 10 by 7 is smaller than 10 by 3. So this second will be a longer will go
correct
deeper,
will take more time.
More time, yes.
Correct. We'll go deeper and will take more time. So when I'm finding max, that means I'm finding which will take more time, because I'm finding t of that quantity, right? So therefore I will always consider the one which is taking more time, which is dividing by a smaller value. Okay.
10 by,
so
again 10 by 7.
It is always
correct.
n by 7n by 10.
Yeah. So but even if you solve it, but you will get anyways log n value and log n on.
And log n.
I mean, in this case, it would be n not n log n. In case of quick shot, it will be n log n. In this case, it will be, since you are going on only one half, it would be order n. You will see that, right? I saw t of n by 5 we saw plus n, right? Here also it is similar. Here it is t of some n by 10 by 7 or some quantity plus order n, right? So as this I solved, it came order n. Remember, median of median. This also will come order n. Fine. But if you go for your quick shot, then you have to consider both, and how to solve recurrence relation with two terms when you plus some plus term is there, that is out of the discussion. So we cannot do that. So in that case, if you solve, then you will get n log n. Okay, I hope it should be fine now. So here you solve it, you will get order n. Just the same thing, like the way I solved your median of median expression. Same thing you can do. Only thing here it is 5, and in this case it will be 10 by 7. Right? Same solution. Everything would be same. Only the log base would be, instead of log 5, it would be log 10 by 7. That's
so max will be 7n by 10 only, no?
Correct. But how will you solve it afterwards? That's what I'm saying. How this order n is coming. So your this term will become t of
n only.
Okay. Now the solution for this is order n.
Order n.
Right. So this is similar to solution of t of n by 5 plus order n.
Yes. Median of
median. The one that I solved. Only thing is, in this case, I have n by 5. In this case, I have n by 10 by 7.
Yes,
so instead of 5, you will have 10 by 7.
Yes.
Fine. Everything else is same. Any doubt? So what did we gain? We worked up a way to find median of median in order n time, and that helped us in gaining a quick shot complexity of n log n and quick select complexity of kth smallest element finding complexity of order n. So initially it would take sorting and then returning the kth position element. So that would take n log n time. Now it is only taking order n time. Okay. Any doubt? Okay. Now the one topic is left. If it is done in 11:30, I will do. If some part is left, we have to address that in live session. This is the closest pair of points. Okay. So what we are trying to do over here is, on a screen you have some random points, fine, and each of these points will have coordinate values x1, y1, not 1, basically x and y coordinate values would be given for each of these points. What I need to find is, I need to find closest pair of points. So which two points are closest in among this random matrix of points, right? So to give you the example, by the way, I hope you all have done this distance formula and all of these things in mathematics. Even if you don't, you have not done, it's not that much difficult. This is the formula to find the distance between any two points with coordinate value x1, y1 and x2, y2. Okay. It was these things were there in your maths course.
Yes, sorry.
Yeah, Manhattan, Mallows,
Yes,
we have done quite advanced in fact.
Maths 1 only.
That's
Okay.
one.
Okay, fine. So what was there, by the way? Let me ask this. So lines, planes, all these things were there. Finding mirror images, mirror points.
Yeah, aunt was going.
The coordinate geometry.
Yeah, coordinate geometry. What were the topics? May I know? I mean, in terms of line and space.
So polar coordinate and linear coordinate. So we also have Python class. So some methods will be, find distance between points, coordinate is easy. But you want to find angle between two vectors, then polar is easy. Stuff like that.
Okay. So fine. And did you guys do planes? I mean, line, but planes.
Yeah, hyperplanes, all in MLT, MLP.
Okay, fine. So that should be fine then.
No, foundation we have not done, sir.
I think in maths too.
Foundation only lines.
Okay, I'm talking in terms of maths too only. So whichever is earlier.
Affine subspace we have done.
Okay, I don't need that part. What I mean basically means lines you have done, right? Completely. In maths,
Sir,
simple
yes,
maths.
yes. Basically, this distance between 2 points we have done, sir.
Okay, fine. So this is, I hope this all of you are familiar then with these terms. So now let's come to the problem. I will not discuss all of this. Okay. So this is the issue. We have this random set of points on our screen and we need to find the pair of point which is closest. So this is another divide and conquer approach. I mean, a problem where we can use divide and conquer approach. How to do it? Any guesses? Any idea? Think about it and tell me. Let's wait for a minute and think about it. Forget about divide and conquer. Any idea that you might have? How to solve it? How to find the minimum distance points? Obviously, don't tell me the brute force way because that would be consider every pair of point and their Euclidean distance, and that would take you. If I consider the time taken to calculate the Euclidean distance is n, I mean constant. So you have n choose 2 number of points. So nc2 would be n into n minus 1 by 2, which is basically order n squared time. So other than that, any other idea if you guys can think of, you can tell me. I will wait for a minute or two.
So can we use the example of the TAs that sir always say? We assign 2 TAs to do this. So we draw a scale and draw a line. You know, this up one TA does.
Sir, we need what we need to do actually calculate every pair distance.
You need to tell me which 2 points are closest.
Okay.
We have to divide the points into two equal halves and then keep on dividing.
Okay, then
Keep on dividing. Once you reach, say, 2 points or 3 points, then you can know the lowest distance. That will be the base case.
okay.
So I think in the merge, what happened in the base case, you have 2 points and you find the distance using this Euclidean, and then when you are merging,
That's the
all you
point.
do is you only select the minimum of the 2 answers. So the merge itself will give us the answer.
Great.
So,
Okay.
Yes.
Great. Fine. So let's forget about this distribution and tell me what happens.
Yeah, but we'll have that cross terms also, no? Just like whether
No,
what we
inversion.
did,
No, inversion is
what we
not
did
there,
for
sir.
that movie problem. Similar to that, cross items also will be there. So you have to find out. Once you divide it into maybe points between these two partitions may be there.
Exactly.
Yeah, that part is true.
Fine. So this is your distribution. Okay. So you find the minimum distance as it is quite observable from this diagram. You divide it into this red color. Let's say at some point this is 1/2, this is the other half. You find the distance between these two, right? You find the distance between these two in 1/2. You find the distance between these two and these two. Obviously, you can see these 3 distances are quite large. So while merging these two, right, while I remove this red color line and merge this whole set together, so I will only consider which distances the minimum one among. So among all these 3, suppose this was minimum, and among all these 3, this is minimum. So among these 2, obviously this is minimum. So therefore, the closest point is these 2, right?
No, we have to consider these 2 points also, which are close to each other, which are in different halves.
So it seems like these 2 points are close. I mean closest, but it isn't the case, right? The closest is actually these 2 points.
So they were
These
in
2
different halves, so they were not considered.
Fine. So they are in different halves. They are not considered. So how will we consider them?
so during the merge, we have to create another function which will take the result of the merge and do another distance computation, and then
Correct.
somehow, yeah, that's
Now
the only way to do it.
That is the only core part of the algorithm, and that is the difficult part. Other than that, everything else is easy. Okay, so let us address the other parts. So what will we do initially? First of all, just to have, I mean, just to put the coordinates in an organized manner, we will sort the coordinates of the point. I mean, you can see the physical or visual diagram of these points on the screen, but when you get in as an input, you will get x and y coordinates. So what we do is essentially sort all the, I mean, keep a array, I mean, sorry, not array, keep a dictionary of all the sorted x coordinate points, and another dictionary of all the sorted y coordinate points. Okay, so sort the coordinates of all the points on the basis of x dimension, and also again in another dictionary keep everything in terms of y dimension in sorted manner. Okay, so that's what we are doing, sorted by x coordinate, sorted by y coordinate, keeping it in px and py. P is basically the total data set, the point set. Okay. Now, first thing is we are dividing it into two halves as suggested. First half is Q, the second half is R. It is very easy to do that. How can we do that? Simply you have Px, right? Px is what? Sorted on the basis of x coordinate. So since all the elements are there on sorted in x way, x coordinate direction, so all you have to do is go to the middle element and separate it. So P is placed at the middle. I mean, so let's say you have 8 element in Px, the fourth element, I mean whatever is your, so not the fourth element, the value, the x coordinate value, whatever is the median x coordinate value, that is your P's coordinate. So that would divide the whole set into half, right? So you go to the Px, see what is the maximum value, find the median, and then you put P, I mean half it over there. So halving is done. Now obviously you can understand that this will go on recursively. Simply you always go to the Px, right? At that level you go to the that level's Px, you see what is the median. I hope you guys can understand that how can you find the Px median, right? So basically at every iteration you go see the Px for that particular iteration, because Px would also change, right? It is recursively calling every time you will pass the Px, and Px is all the points x coordinate sorted in ascending order. So at every iteration it will get different, I mean it will be different, right? Corresponding to which half you are present in every recursive call. So you will go to Px, you will find the whatever x values are there. From those x values you will find the median x value, and in that median x value you put the line, that is your half. That's how you will, every time you will half it. Okay, fine. Now that is done. So once this halving thing is done, now the most important part comes. This is the example that I took. Okay, now see this. As we saw that the main problem was we can half it and go on halving it recursively, and we will basically at the base level we will end up at 2 or 3 points, and you can do that. I mean you can terminate your algorithm at level 2. I mean when you have only 2 points in your half, or you can also terminate at 3 points. Only thing is if you are terminating at 3 points, you have to calculate the distance for 3 points, mutual distance between these 3 points at the base level. If you are terminating at 2 points, then you can just calculate the mutual distance only once, because there is only one distance between 2 points. So whatever it is, but basically you find the mutual distances, pairwise distances among 2 or 3 points depending upon which one you choose in the base level. And while merging, in the merge, I mean when you do the merge phase, non-recursive phase, in that part you have to take care of the such elements which are close to the, which are very close to each other, but which belong to two different halves, and that's why their distance was not considered while finding the minimum distance. So like in this case dq and dr, as you can see in the diagram, dr is lesser, but I might have a number which is I might have a pair of points which is actually lesser than dr also, right? So but I will not, I'm not considering that. So how to do it? In order to calculate, I mean in order to consider the dots or the points which are near to the red line, we will consider this region. On both sides it is delta distance apart. Okay, And by the way, what is delta? Delta is the minimum among these two. So on the two halves, whichever is the minimum distance that you get, that minimum you will put in delta out of dq and dr, right? So we found the minimum on both the halves. Whatever is the least within those two minimum, that would be equal to delta. Once I get delta, while in the merge phase, I will put, I will create this separate region of delta and delta on both sides. And within this region, I will check, are there any points or not? By the way, why did I create a delta length region? The reason is because I need to find out points which might be near to the middle line and which are there on different sides, and that's why their distance was not considered. But those points should be located apart by the middle line, not more than delta distance apart. Actually, strictly less than delta distance away, right? Why? Because if it is more than delta distance away, it doesn't make any sense, because delta is lesser and I should return the minimum value at every case. So that's why we create a region on both sides of maximum delta, right? So that bounds us to only check for element within this region which can be delta distance apart at most. I mean, not exactly delta distance apart. If any point is here and here, it would be 2 delta distance apart, but that's a kind of an upper bound. Okay. So now how will we inspect? Okay, this is very important. Now see, again we will consider that I have broken down the region, which is this delta region, right? This delta region, to both side it is delta. I have broken down into these 4 smaller cubes each level, and each of this is delta by 2 region away. I mean delta by 2 distance apart. Each of these 4 small parts. Now I am making a very rigid claim. The claim is each of the small boxes cannot have more than 1 dot or 1 point. Okay, I'm claiming that each of the small boxes will not have more than 1 point in them. Fine. Can someone think why?
Yeah, because it was, if it is on left hand side and if they are there, then that would have been the closest pair and the delta would have reflected that. So it will be a kind of a counter example of that you found the minimum.
Correct.
That is
So exactly. So if it is within the, if I have more than 1 point on one side, then that means in one box, I mean, so if I have, let's say,
delta would change then.
exactly. So let's say within only this box, if I had more than 1 point, now in this box no point is there, but suppose more than 1 points are there, so then that means everything is on one side. It is on the left hand side of red line. And if I have more than 1 point, that means it would be the least distance, because it is only delta by 2. So what can we, by the way, what is the maximum distance? If I have 2 points in the same box, what can be the maximum distance between them?
Diagonal.
Diagonal. So
Diagonal.
let's say 1 point is here, another point is here. So what is this distance?
Delta by root 2.
Delta by root 2.
Okay, so root 2 into diagonal is the distance, right? Root 2 into diagonal. So that means root 2 into diagonal, sorry, root 2 into side. Root 2 into side. So root 2
730, sir.
Yeah. So
That is why all these diagonals and sides are coming.
So root 2 into delta by 2, right? Side. So what is this? Delta by root 2. So delta by root 2 is what? I think root 2 is 1.414. So delta by 1.414, which is obviously lesser than delta. So that's the point.
Delta by anything is lesser than delta only, sir. I mean, except if it is less than 1.
So therefore, I can always guarantee that each of these small boxes will have at most 1 point. Okay. Now what can we claim from that? I mean, if each of these boxes has at most 1 point, then I can say that suppose I take a point over here. Okay. And again, each box can have at most 1 point. So So, and I need to find such a point which is on the other side of the line and which is at most delta distance away. What is delta? This is delta by 2, this is delta by 2. So which can be at most here, right? So for a point located in this box, I need to check a point which can be over here. Not I need not to go any further. No need, right? I need to check the presence of any point within these two lines away. Not even two lines, just two box away. Likewise, it can be a downside also, right? So for this point, it can be over here also. Some point can be over here also, or over here also. Fine. So that means essentially I have to check this whole region. Fine. For the point. Now it is a kind of, I mean, we kind of go for upper bound because it doesn't matter whether we check
You
8.
have to check for delta, right? Distance.
Yeah, check
So
for any.
wouldn't it be like 2 points? So like 2 boxes apart from the center. So 2 boxes apart, right or left, maybe.
They are in the same half.
They are in the same half, right? Why do I need to check on the same half? Actually, we will check. I mean, I'm telling you, the thing is, first of all, what will we check? I have not addressed that yet. What we have told is, if I have a point over here, I need to check the presence of any other point, maybe over here or over here. So for every point within this region, within this whole region, right? Every point within this whole region, this whole part. So every point within this whole yellow part, I have to check that. I have to check which boxes. I have to check this many boxes. So particularly for this one, I have to check 2 up. So 1, 2, and 2 down. 1, 2, 2 down. These 4 boxes I have to check. But this is quite a rigid approach. I mean, because first thing is I have only need to check on the other hand, on the other side of the line, and it can be at most these 2 boxes apart. So only if I check 4 boxes, then also it should work. But we don't go for that much rigid approach. What we do is, doesn't matter. I mean, as long as I'm keeping it a constant number, if it is 4, if it is 8, if it is 16, it is fine. So what we do is, at least in the code written over here, what we are doing is we are forgetting about that much of the problem, and we are checking this whole part, this whole 2 up, 2 down, the whole thing on the same side, on the other side. But practically speaking, you don't need to go for this much checking. Only need to check on the other hand, I mean on the other side, these 4 boxes. Okay, that should be enough. But anyways, in the code we are not doing that. We are checking for all the 16 boxes. But it doesn't matter, right? Because if 16 boxes is a constant, 4 is also a constant. So for every point, so let's say now take an example. So what we are trying to do now is, in the merge phase, what we will do is, we calculated delta by finding the minimum of, let's say on this side it is d left and d right, whatever minimum distance was there on left side and right side. Once we calculate delta, what we will do is, we consider all the point within this delta region of the red line. So first point, let's say we go from the bottom to top, first point is this one, right? So since this point is present within this cell, I will check 2 cells up, 2 cells down. So which is basically 2 cells up is this region, and 2 cells down would be, I mean, this whole region. Let's say this much. So within this, I will check all the points. Okay, so that means what? I will check this point. I will calculate the Euclidean distance between these two. I will calculate the Euclidean distance between these two, although unnecessary because on the same side, but still as a part of the algorithm it will be done. But you can optimize the algorithm and only check these 4 cells as well. That's what I already told. So basically I will calculate the distance, and obviously it would be, I mean, you will find if it is minimum. Calculate all these distances, all the points present within this yellow region, corresponding to this point, you will find the pairwise distance, and if it is lesser, then you will update the minimum. One variable where the minimum distance you are storing, in that minimum variable you update it. Okay, suppose you did not get anything, like in this case you did not get the minimum. Okay, so then you will update it. Sorry, you will not update, you will go to the next point within this region, which is which one? This point, right? So within this region you get this point. Again, particular to this point, go for 2 cells up. So 1 cell, 2 cell over here, 2 cells down over here. Now compare. Then again, if you get minimum, fine. Or if you do not get minimum and on the same sides only you got minimum earlier, that is still the minimum, then you can just keep it as it is and move forward to this point. Check for 2 cells down. Check for 2 cells up, maybe somewhere here. Right, and find the minimum. So again, you after that you get minimum, fine, or move to this point. So this is how the algorithm will work. So once you get that either of the DL or DR, whatever is the minimum, set a region of delta, check all the pairwise distances between all the points present inside the delta region. That time would be taking constant. I mean, for each point it would still take constant time, because I know that I'm only checking some specific part of the code. I mean, some specific part of the region. Only 16 cells I will check. Okay, if I would have gone for the whole region, then it would take n time. So it is constant time, 16 cell, whatever number of points are there within those 16 cells, even if it is large, still we will say it is constant time. Fine. So that's the merge phase. You find the minimum on both sides, set a delta region, find the distance between.
Here it is given, check each point against 15 others. 15 others.
15 others means 15 other cells. That's what I said. You are in one box. 2 cells up and 2 cells down means what? Let's say this one. 2 cells up.
4x4 box. And we have proven that there cannot be more than one point in any box. So that means you have to check 15 other boxes.
Correct. Right, now it might so happen that 15 other boxes you have no points. I mean, within this region you have no points, but like in this region you have 2 other points. This is 1 point, this is 1 point, right? So that depends. And if you get a minimum value lesser than DL or DR, then you update the minimum. If you don't get minimum, then proceed with it.
The next 15 points it is saying, scan SY from top to bottom, comparing each P with next 15 points in SY.
No, it's mistake. It basically means the next 15 regions. 15 points in the sense it might so,
But sir, each region will only contain 1 point. So it is the same as saying.
No. It's
That's
not
a typo,
same.
yeah.
It's a typo.
15. Worst case is 15.
Every region can contain 1 point, but it will not. It is not correct to say every region will contain 1 point. It's how will that
You are
happen?
going to still check, right?
I am checking, that is fine, but this is the typo. This is not correct. With next 15 points is not correct, right? Because it might so happen that next 15 points means what? Maybe the 15th point is somewhere much farther away. Why will I check that? Right? Like consider for this point itself. How much you should consider? You should check till this region, right? How many points are there within this region?
3 points.
I mean, forget about this. This is the one I am considering. Other than this, 2 points are there.
Yeah.
So only these 2 points I will check. And I'm checking this 15 cells. That is fine. You have to check the 15 cells. But if you don't get points, then why will you write it as 15 next point? Maybe the 3rd point is over here. I don't need to check between these 2 because it is so far away. Why will I check? Time waste. It is typo.
Yes. But even if we check 15 points, it's constant time, no sir?
It's constant time, but yeah, maybe okay. But in that case, I will.
Sir, now we have become advanced students, right? It's not just a time complexity. We should
It's also about timing. Correct.
Amortization, right? So
Correct.
why unnecessarily waste time?
Exactly. So it's better. I told you even the better case. You should actually, if you are very rigid, you should consider this region only, because it is on the other side, and it should be not more than delta.
So suppose, sir, the point is located on the left part of this delta 2. Left part of this delta 2.
Left part of
The dotted line, the left part of the dotted line. Suppose the point is located on the left part of the dotted
can you
line.
tell me? Okay, wait.
It is not possible, right? That's the argument we take.
Sir, the
Where do you mean the point is located? Which point?
first square, the lowermost square, the left lowermost square.
Okay,
Just above that, above that.
above that. Okay, here.
Suppose it is located here. Then in the border of that.
Okay,
Then the point can be located. If it is less than delta, it will be located.
point number 1. This is on same side. If I'm considering with this
So,
point,
if another point is located on the other side, delta distance away. On the other
It
side,
will be more than delta.
in the other side of the red line. Other side
Okay.
of the red.
Other side of red line, delta distance away. Here,
No,
here,
no. Yes, closer to that. Closer to that. That is more than
Yeah.
delta. Still closer.
it is delta by 2. It is fine.
Closer
It
to
will
that.
You
Then-
mean here?
Somewhere close to the red line.
Okay, fine. This whole thing is delta by 2, na? This is delta by 2.
Yes,
So
yes.
this whole thing is delta. So you can just consider it is fine. It is closer than delta. Then what do you mean?
So in that case, which zone we have to check?
For which point?
For
This-
this point, the point located.
Let me name them. Wait, A, B, C. For which point?
The C for C.
Okay. For C, first of all, if it is in there, the maximum thing is you will consider 2 up, 2 down, 16 cell. So, and below whatever it is. Oh, sorry, not 3, 2. And whatever below bottom part.
Okay.
So let's say this is the red line. Then again one box came. Yeah.
We are we are taking a square box. Like I know in billiard table we take a triangle, right? Imagine if that's a square, right? Every ball we are putting a center and looking around x coordinate to higher or lower and y coordinate to higher or lower delta basically. That's all we are doing. It's a window with respect to the point in question. After where in the vicinity we are finding the distance. If we don't find any other balls or points, then we just do that.
Yeah, it will not happen, right? Because anyway, if you just put it over here also, it is anyway delta by 2 plus delta by 2. Delta is exhausted in this part only. You cannot go on that part. But anyways, that's why we kind of have an upper bound of these 16 cells. You can reduce it to 4 cells.
If you want to look for C, if you want to see a closer point to C, then you have to search on the right side, sir. You have to search on the right side.
See, this merge phase and this delta and all this trouble that we are going into, it will only be required for points located on 2 different sides.
Yes, I know that.
Okay.
Suppose a point is located on the other side of the red line.
Okay.
From C.
Okay.
So we can search in the right side, right? For A, we were searching on the top side. Here we have to search on the right side.
No, we are not searching on top or right or anything. We are searching the 16 boxes in which it is.
Yes.
Yeah. Forget about top right. 16 boxes, whatever is there, I will search and I will find the minimum distance. Okay. But that is quite a upper bound kind of approach. You can make a much more rigid approach. You can make, okay, I will not search the 16 boxes. I will only search the boxes which are on other side. Point number 1. I will only search 4 boxes, 2 up and 2 down, which are, because that would be delta by 2, and that's why it would be lesser than delta. So you can also do the same thing with a 4-box approach, right? But that is, I mean, it is quite rigid. Sometimes you may miss in some kind of funny kind of orientation. You might miss a point which is still closer, but you did not, could not see. That's why we take what should I say, a tolerance, and that's why the tolerance limit, you can make it 8 boxes or 16 boxes. Here we are following, we will check the 16 boxes. to be on safe side, so that we do not find anything, we do not miss any distance which is lesser, the least or the minimum, right? So it doesn't matter constant how much it is constant there. The idea is you will have this delta region to cater to points which might be located on two different sides, and that's why when the normal algorithms divide and conquer phase was running, its distance was not calculated pairwise manner because it is located on two different sides, and divide and conquer is only working on side basis manner. So on one side it is calculating the distance between pairs of points located on only one side. So that's why this delta region and is coming into action in the merge phase, when you are merging the distance found on left and right side, right? And you compare all the possible distance in this delta region to find the minimum one. Okay.
So for C, if you want to apply the rigid strategy, then which boxes you will check for, sir?
Only these four.
Which ones?
Point is to the left of red, then you search right 4 boxes.
For C, sir. Okay.
For C only I am telling.
Okay. Okay.
If it would have been on the same side, or if it would have been on the same side, this part, then it would have been already calculated in the divide phase.
Yes,
Right.
yes.
But this is an extra kind of information or strategy that I discussed about. This is not discussed in the lecture. The main part is simply you can search the 16 cells and be safe with the possible points. Okay, so this is a pseudocode. The code for the exact code for this algorithm is not discussed. It's a kind of pseudocode, and most probably you will not getting direct or how should I say, coding question or any code snippet kind of question from this, but conceptual question might come. Okay.
So video game. I think the sir was talking about video game.
Video.
High resolution TV. If you're playing a video game and there are 10 to the power 9 pixels, right? Or 2 to the power 9. So our search space closest pair could be 2 to the power 9 into 2 to the power 9. So we're talking about 2 to the power 18 search
Correct.
space. Yeah, it's a huge complexity now. So
Exactly. Yeah. So
That's why GPU, right?
that's why GPU. So, yeah. See, initially we did not have all these hardware resources and all so many utilities, right? So that's why we had. We need to care about these algorithms, how to optimize, how to extract a little bit of optimization by using a different approach, thinking of some intelligent idea. Now you have all these stuffs available, so you can do. Anyways, fine. I think that's it. We have discussed all the topics.
So quiz 2 will have topics from weeks 1 to 8, right?
5, 6, 7, 8. Mainly 5, 6, 7, 8.
Okay. That is next week only. Quiz 2 is next week only. So it is complete.
Yeah, quiz 2, I think it is on
6th.
6th, right? Yeah, quiz 2 is on 6th.
all about Dijkstra and everything, right?
Dijkstra is week 5. So yeah, week 5, week 6, and 7 and 8 would be there. Obviously, if you don't understand week 4, you will not be able to write anything in week 5. So
We have to quickly select all our algorithms or topics.
just practice the normal questions. It could be enough.
Sir,
Sir, could you take my question on inversion?
Okay, I will request you to put it on Discourse. Okay, or let me just copy it. I don't want to discuss it now. Quite tired. Let me just.
I have 2 naps.
just one question: how to see the result?
Sorry, what, Ritik?
I have
No,
had, I have had 2 naps during the lecture.
Sorry, Ritik, I couldn't hear you. Can you repeat?
Sir, I have had 2 naps during the lecture. It's like
Acha,
so
acha.
stupid.
Someone else is asking. Sorry. I thought Siddharth, right?
how to see the answer? I mean, the result. Sorry, how to see the result of quiz 1?
How to see the result of quiz 1? Your friends will be able to help with that more than I. So
It's
Go to
in
the,
the
go to the,
dashboard.
go to the
It's in
main
the
dashboard.
First thing, what is dashboard?
He is not having the, I think, dashboard.
My current course.
Yeah, my current
Just
course
one
is
second, I will present my screen. Then tell me how to do that.
Prasid is from
Okay,
IIT.
maybe we
I
can
think he is not
Yeah,
part of
stop the live stream if you like.
Prasid, wait. I think, do you have workflow? I mean, obviously you
yeah,
have workflow, right?
yeah.
Have you, so where did you register for this course? I mean,
SSP portal.
okay, fine. So you go to workflow. Fine.
And this is this thing which
Okay.
we saw our all courses.
Fine, I know. Okay. You don't have to share the screen. Wait, Prasid.
Okay.
I'm telling you, you have workflow. Go to your workflow, right? That log in with your SML, and then you can see the course. I mean, normal workflow where the courses come in there. You can see. I hope
But in a workflow we can't see